Hi, everyone. Um, all right, so now let me share my screen. All right, so I think we can go ahead and get started. Um, just let me make sure that I have access to everything here. Okay, yeah, I think we're all set. Hi, everyone. Welcome to the Python Fundamentals class, week 1. My name is Siavash, and I'll be your instructor today. Um, so in the next few hours, we're gonna go over these topics. So this is gonna be a class on Python basics. The assumption here is that this is for Python beginners or people who are not familiar with Python at all. So the concepts that you may see here could be very basic. Um, so in case none of these topics are new, um, you may skip this one and go to second week. Or if you feel like that some of these are new later in the day, maybe you want to join for that part. But this is what we're going to cover today. Um, so, yeah, so we'll begin by an very brief intro to Python, some basic concepts, why Python, why do we need to code in Python, and then what are variables and data types in Python, um, and then how to go from there to bring in operators, arithmetic operators, logical or comparisons in Python. How do you compare, for example, how do you combine logical operators such as and or? How can you make use of the same things with arithmetics, bringing integers into the play? And that would be our third topic. And we'll have a break. And then after that, we'll use all these topics to learn more about if and else statements. And from there, we go to loops, where we learn about the for loops and the while loops and how to control these loops with break and continue, and how to make our code modular with these tool sets. And then we also learn about functions in Python, how to define functions, what are arguments, parameters, and we'll see tons of examples of all of these topics. And then at the end, we'll go through more popular data types in Python, which are lists and strings. And this is where we stop for this week, and we will continue this with more data types and a little bit more about slicing in these data types and indexing for the next week. So before I move forward, a couple announcements as you saw in the instructions in the beginning. So we have a TA. So if there are any questions, you're encouraged to ask at any time during the class. So I will pause between each of these topics as I move forward. And then I try to see if there are any questions unanswered. But at any point, please write your questions in the chat, in the Q&A, and our TA will respond to those questions. So yeah, I mean, I will also go over the questions to make sure no questions are unanswered between these topics. But within the topic, I try to make sure we keep the flow because we have so many things to cover. I'll try to pause after each topic is completed. So the other thing is that I want to make sure that the class is interactive and everyone participates. So I will provide after I provide the content, I will make sure I ask some questions, and I'll make sure that I see the chat to see your answers and go over them. And probably if you want to discuss something, please let me know. I'll unmute you and then we can discuss that. But since we have so many topics, we also need to make sure that we cover everything. So it would be great if we can make this within the context of the class. And if there are more advanced questions or out of context questions, I try to answer them towards the end of the class, or maybe we can skip them for this class, and then I reach out for the answers afterwards. So yeah, I think you're all good for the announcement. So a little bit about myself. So my name is Siavash. I'm a Python and machine learning instructor at Interview Kickstart. So I got my PhD in aeronautics and astronautics from University of Washington in 2021, and then I joined Microsoft as a machine learning scientist. So in case you're wondering what is there going from AeroAstro to Microsoft, so my research at PhD was mostly around data-driven control optimization and the use of reinforcement learning for multi-agent systems. So I was in that AeroAstro department, but mostly working on machine learning and reinforcement learning projects. Just to make sure I'm addressing the question in the chat, record members. Yeah, so it's okay, Sam. So this is, I believe this is the system is designed so that we cannot see the cohort. So please feel free to write your questions in the chat or Q&A, and it will be answered by our TA. And for the discussions, I will make sure that everyone's who want to discuss are unmuted. All right. So, all right. So these are the lead code questions that we'll see today based on what we learn as we go from topic to the other. So one thing that I need to note here is that these lead code questions is to show you that even with this very basic knowledge of Python, which you will build upon for the next upcoming weeks, you can solve some problems and make sure that actually you can run them on LeetCode. So the goal here is not necessarily to optimize your code or improve the time or memory complexity of the code. It's just to see how with just a couple of topics that you cover, you can actually solve these problems. So for improving the codes, for optimizing them, there are data structure and algorithms classes that you probably see all those optimization methods and how to improve time complexity. But here the goal is just to solve these problems with the toolset that we learned today. All right. So first of all, this class would be you can benefit a lot from it if you can code along. So if you want to run Python, if you haven't done that already, these are the few tips. You can go to python.org, download the latest version of Python, and then the alternative option is to go to Anaconda, get Python from there, where you'll get all the side software with that, like Jupyter Notebook, or if you code in Spider editor. And then you can choose any editor of your choice, basically. So PyCharm is one which is very popular. I personally use Visual Studio Code, but today in this class, I'm gonna use Jupyter Notebook, and whenever I'm gonna code, I will just go to this view, and I have my notebook ready here. But feel free to use any editor or any notebook of your choice. Google Colab is one other choice that you can use. Uh, go. Sorry. All right. So with that, we're gonna begin with Python basics. All right. So why Python? So Python is a very simple, a highly readable, and a pretty consistent programming language. So um, this class would be all about Python and not other languages. But if you compare at any point, you'll see how close a programming language can get to English as possible, and that will be Python. So it's pretty straightforward to learn and pretty straightforward to uh, scale your learning. As soon as you learn about one topic, you'll see how other relevant topics, you know, will come along. So Python has a huge community. It's a vast ecosystem, and there are so many ready-to-use frameworks, libraries, and modules that you can find. You can just take a very quick search on Stack Overflow, for example, to see uh, how much content you can find, or if you wanna, for example, at some point fine tune a machine learning model, you'll see how much stuff is out there that it's ready to use, open source, and free, basically. So yeah, you can also take a look at GitHub. You just search for some model or for some piece of code, and you see how many items will be available to you. So this class is mostly about Python and how you can use it for machine learning and data science, right? So specifically for machine learning and data science, um, there are popular, I mean, very popular libraries such as Pandas, NumPy, Matplotlib, um, and so many other libraries, which are basically designed particularly for Python. So we will see some of these in the upcoming week, but feel free to take a look and see what is out there, which is solely designed for Python versus other languages, and it is kind of impressive. So for APIs of cloud-based systems that you want to use out there, for example, AWS or Azure or Google Cloud. Sorry. And the languages for distributed programming, such as PySpark or machine learning packages for deep learning, such as PyTorch or TensorFlow, you will see that the main language which these APIs are designed for is Python, which is great. And the last thing I want to mention is that the applications of Python that spans all over the place, from sciences to engineering, for both industrial applications and academia. So I'm coming from an engineering background. Back in my PhD for my research, we were using Python, specifically the SciPy package, for all the optimization stuff that we did. now that I'm a machine learning scientist working on some more applied stuff, um, now we are still using Python, but different packages, and it has always been very easy to work with it. So yeah, so this was some motivation about why Python, and then now we get into a little more syntax and basics of Python. So um, in Python, we work with blocks of codes, right? And the way we define each block versus the other is the indentation, use of indentation. And by that, we mean that, so if you're, for example, at one line, let's say line 1, and you're writing a piece of code here, right? Then on the next line, if you want to make sure that you're writing this in a code block, then you have to add some space, right? So this the number of spaces that you use here, and then you add your code, is arbitrary, it's optional. But the best practice is to make sure this is consistent within your code. You can use one space, two space, or even you can use one tab, which is usually 4 spaces or 3 based on the settings of your editor. But this is very important in Python. As soon as you add this space, then the interpretation is that now this part of the code is within that block. So make sure that you follow this best practice. And whatever I say here, and it may not make sense. You will see a lot of examples, a lot of code on this. So don't worry about it. So definition of data types in Python is dynamic, which means that if you have some integer, for example, that you want to assign to a variable, you don't need to specify what is the type of that data. So for example, you have a variable called a, and then you have an integer, let's say, I don't know, 42. You want to assign 42 to a, then you don't really need to specify that this is an integer, right? So this is defined dynamically in Python. It gets the data type, and for those cases which it gets a bit weird, then it will pop out an error, right? And we'll see examples on this as well. So like any other language, Python has this print function that you can output the results of a part of your code. But it makes it very easy in Python using, print, and then there will be parentheses, and then you put whatever you want in this parentheses, and that's it, right? And you can display text, numbers, results of expressions, output of functions, and you can also use this. So when you use it like this, it goes to the next line automatically. So you can simply just remove everything inside it with parentheses, and then it helps you to go to the next line in your output. One thing to note before I go to the next bullet point is that make sure you're using Python 3 and any version after that. So I'm not even sure if we still can use Python 2. It could be deprecated by now, but what I do know is that printing, has a different view in Python 2. So make sure that if you're coding right now, or if you want to do it in future, make sure that you use Python 3.0 and up for whatever we see in today's lecture. All right, and then the other important thing about Python basics is commenting in the code. So commenting is when you want to add some description or explanation about a piece of your code. And this is really important because if you write a code, you put it out there, and some other colleague or some other folks want to use that code, then this commenting helps them out in learning what each piece of the code really means, right? So you can do this in Python in a couple of ways. So one way is if you want to comment out one single line. So for example, you have your code here, right? So this is your code. And then before that, you want to add some description of what this piece of the code works. Then you just put this pound mark or the hashtag before that, and then write your comment. You can basically write anything, and it won't be interpreted in the when the code is compiled. So you can either add this manually, or you can just go anywhere on this line and press Control plus slash, and then you'll see that this line gets commented out automatically. So if you have multiple lines of code that you want to comment out, instead of going through each one of them and put this pound symbol before each line, we can just add triple quotes before and after this part of the code. And this turns this into a large string. And then it basically doesn't have any effect for the remainder of the code. All right, so let's go over this first implementation. Let me keep this. All right. So now here's a good chance for me to also introduce you to the Jupyter Notebook. So as you can see, there are different blocks that I can add my code, and you can add text in between your code, and you can also make your code modular. You can add some code in here and then run it independent of another block, right? So here I'll go ahead and write. I make sure that here I'm on the code option. So the markdown basically means that if you can add a text here, right? So make sure that this is on code. And then I go ahead and write, this is a single line comment, right? So as you can see, and there's no hashtag behind this, right? So there's no pound mark. So as you can see, everything is in black, but then is turned in green, and then a different color is assigned to dash, right? This is because this block of code is set to code, and it interprets this as a line of code, right? So if you go ahead and run this cell, right? So it realizes that there's some invalid syntax going on here, right? That's because I'm not really writing any code here. I just wanted to add a comment. So I go ahead and add the pound. And as you can see, everything turns into one single color. And now it's turned into an italic style, right? Now, if I go ahead and run this, nothing happens because it's just a comment, right? So let's go ahead and add the other one. So I have triple quotes, and then here I will say this is a multi-line comment, right? So basically, this is giving us a string, right? Which we'll see what it means later. But the thing is that now you can have multiple of this line. So this is a multi-line comment, and this is the second line of the comment, right? So this, if I run this one, the output wouldn't be empty because this is now a string, and Jupyter Notebook, if there is, if this is the last command you put in Jupyter Notebook, then it prints the value of that. So you'll see that the value will be something like this, but this has no effect if you have some code afterwards. So for example, if I write print hello world after that, then you can see that we'll get the output of this print, right? Because this was just a single string without any definition, without any assignment. So for now, let's think of this as multi-line commenting, and this way as single line commenting in Python. And this is how we use print. And as I mentioned, if there's nothing, no argument inside the print um, like this, then it takes you to the next line. So let's do this. Let's do print hello world, print nothing, and then print hello world again. And as you can see, it prints hello world, one space, and then hello world again. So it basically moves to the next line. All right. So let me go back here. All right. So that was with Python basics. And now we're going to get into more fun stuff, which are variables and data types, and then operators. So let me take a quick pause here. Yeah, so I see a question on the Q&A, which is asking in PyCharm, it is asking to select environment, which is virtual environment, pip environment, poetry, and conda. So it's basically whatever you choose as your editor, and then the way you pick, install Python, that would be the option that you can set for your PyCharm environment, right? So, for example, you can have the conda, which I introduced earlier, where it actually, after installation, it comes with Python, Jupyter Notebook, everything. So you can go, it also comes with PyCharm, right? So you can go to PyCharm, and based on the versioning, whatever of your installation, then pick one of these. So I haven't seen poetry, but virtual environment is another way you might want to go with. So you can have that and basically install whatever package you want on that virtual environment. So I usually go with the conda because that's how I installed my Python. But that's up to you which one to choose. So how segments. So let me see. We're live. Okay, so answer live. So how are statements terminated in Python? So basically, there is no need to put anything like semicolons or anything at the end of the line in Python, or at the end of any functions, right? So that indentation that you add to your code basically defines when the code has begun and when it's gonna be terminated, right? We will see a lot of examples on this. So the next question is on the tools. For example, why do we use Jupyter Notebook? Is it more useful than VS Code? And how do we compare these kind of editors? And is there any caveats with different tools? Not really. So it's basically a matter of personal choice. The thing about this specific comparison is that VS Code or PyCharm, there are editors. You can write your code, and then you can write your full code, and then do debugging within that, right? So the thing about Jupyter Notebook is that it's a notebook, so you can write your code in different cells. So if I go back to this view, um, so you can write code in this cell, you can run it, right? And then go to this cell and run something totally independent, or maybe you want to use some variables that you defined from the previous code. But it's nice in the sense that you can add text within that, and then it actually becomes a notebook that it also contains the code that you can run within your notebook. So you see many classes or many projects out there that they provide a notebook, and the notebook contains everything, both the notes that the instructor wants to teach and also the code that you can run while learning the material. So one thing about VS Code or the other tools such as PyCharm, those kind of things, is that um, usually when you want to send your code to compute clusters, which is out of the scope of this lecture, but when you want to use cloud services, then there are instructions for those editors to easily connect them to cloud and virtual machines, those kind of things. Available, not what it is. So Jupyter Notebook is asking about kernel options available are Pyodide and SQLite. So for me, the kernel, I mean, it depends on how you install your Jupyter Notebook. So if these are not working, the drop-down options that you provided are not working, it basically means that um, you don't have Python installed, or it's not compatible with the version of Jupyter Notebook that you have. So um, if that's the case and you cannot run any code on Jupyter Notebook, give the Anaconda a try, right? But so about SQLite and Pyodide, I need to take a look. So I'm not sure what are the other use cases than Python for these kernels. Okay, so one last question, and then we go to the rest of the material. So, do you see Jupyter notebooks used much in industry? How so? Um, so I do. I have seen Jupyter notebooks used in industry, but not in its current way that I'm showing you on the screen, right? So usually each company have their own infrastructure and setup to use their own or some third-party compute clusters. They have all their settings with some editor, let's say in this case, Visual Studio Code or PyCharm, whatever. And then for the part that you can have access to some notebook, so you can have access to notebook on Azure portal, right? So there will be options to switch to Jupyter notebooks. So basically you can use exactly the same view that I'm showing you on this page, but it's connected to some internal internal compute within the company. And yes, so the last question is there an autofill functionality in Jupyter Notebooks? How to enable it? Um, so I, yeah, I need to take a look at how to enable it. So it should be, you should be able to find it somewhere on the option. But I mean, so as you can see, when you write something and then you click on tab, then the autofill should work. It should be activated automatically when you install Jupyter Notebook. So you can see the autofill functionality here, right? But how to activate or deactivate it? I need to take a look where that was. So it should be somewhere in the settings, which I'll look into. All right, so I'm gonna continue with the rest of the content, and then we'll get back to the questions. All right. All right. So let's go over there. All right. The next topic will be variables and data types in Python. So what are variables? What are data types? So variables are basically a container to store values for later use. So you store these values, and later you want to use them in some operation, or maybe you want to change their value, or maybe you want to keep them as reference, but they work as a container that you can use throughout your code, right? Um, so again, this defining a variable in Python works in a dynamic way, which means that you do not need to declare the data type when you define a variable in advance. Python learns what the data type will be, right? So that was variables. How about data types? So the data type is the way that you specify the type of the value and the allowed operations on the variables that you define here, right? So common types of data types are integers, floats, strings, booleans, and there are other data types, but these are the mainly used ones. All right, so now let's see some examples of data types here, and then we switch back to the code. So we have integers, which are whole numbers, and they could be positive or negative or zero. And this is how you define it in Python, right? So you just add a variable. This variable can have any name. You can have a is equal to 10, or you can have bi is equal to, I don't know, -5. And you can have c underscore 7 is equal to 0, right? So floats are the other types of numbers that we can define in Python. They're decimal numbers. They could be positive or negative. This could both also be 0, right? So, and then you can see that now you have decimals here. So, for example, b is equal to -6.2. If you want to define 0, you can go, for example, c is equal to 0.0, something like that, right? Or you can have b is equal to 2.7. So one thing to note is that when we say Python is, data type definition in Python is dynamic, it means that it realizes, for example, here you're adding a dot, and this dot is defining decimal point, right? So if you, for example, go ahead with a is equal to 10, then the data type assigned to a will be integer, right? But if you go ahead and set a is equal to 10.0, then it assigns float, right? And we'll see examples of this in a bit. So we also have a string. So strings are sequences of characters, and if you want to define that in Python, you should enclose them in quotes. So you can use both single or double quotes. So for example, this is one way of defining a string. C is equal to a mat in double quotes. or C is equal to Sarah in single quotes, right? So you can also have another string. I don't know. You can have Python, and then you can have a space here, then class, right? So whatever you put into these double quotes will be counted as one single string. And then the last one is Boolean, which is basically a flag. So it represents whether the variable is true or false. So you can think of true also as one if a key is on or it's off, true or false. So D is equal to true, or for example, A is equal to false. So both of these are valid variables in Python, and yeah, so this can help you with conditional statements. For example, if some part of this is true, then do this, and we'll see that in the next section, right? All right. So let's see. Yeah, it's time to see some of these in the notebook. So let me go uh, here. All right. Okay. So I'm gonna start here by defining a new variable. I call this variable name, and I set it equal to math, right? So I want to see what's inside this variable. So I will print it, right? So this is how you assign a value. You have math, which is the string, and then you have this variable that we call name. And as you can see, um, the the color coding here makes it different between strings or integers, or are these symbols, and for example, is it a function? So I will go ahead and run this. So to run this in Jupyter Notebook, you can either click on run, or you can press control plus enter. And then as you can see, the output will be the string that you just defined and you put into next, right? So you can also see what is the type of this variable. So I will go ahead and write print the type of this variable name, right? So this is what, let me go one by one here. So this is our print. So this is where it begins with this parentheses, and this is where it's closed, right? So whatever goes inside, print is trying to display to the output. So type is a built-in function in Python, which shows the type of this variable. And then whatever goes inside this parentheses will be, the argument given to this type. And this entire part gives us the output, which is the type of that variable, right? And then we will print it here. So if I go ahead and run this, you will see that it says that this variable belongs to a class called string, str or string in Python, right? So what I'm gonna do is I'm gonna go ahead and take this one and bring it here and put everything in one cell, and then remove this. So basically, this is our variable. This line prints the name, and this line prints the type, right? All right. Now that we have seen a string type, let's see another type. So I'm gonna say, let's say the age is equal to 30, and I'll go ahead and print age. And again, I also want to see what the type of this variable, right? I'll run this. So it says the variable age is 30, where we assigned it, right? And the class it belongs to is integers, right? So now let me go ahead. Let me also make sure I'm commenting here to give a better you know, self-explanatory view. So we have string here. We have a comment called int here. Now I want to show you the other one, which was Boolean. So I continue with different information about Matt in this case. So for example, we say is married, and we set this equal to true, and then so this means that is married is a true variable. So basically, yeah, he is married. So um, we print is married, and then to check the autofill, I'll go ahead and put is underscore m, and then as soon as I click on tab, it will autofill, addressing that question you had previously. So, and then I also want to see the type of this variable. Yeah, it is true because we defined it to be true, and the class is bool or boolean. And then the last one, I just go ahead and copy this piece of code here, is a float called GPA. We set it 3.7. And then if you run this, it gives us the value and then the class, which is good, right? All right. Now, let's see another thing. So let me go ahead and add some cells here. Okay. Now, I want to try to see what happens when we overwrite a value. So let's say we have age is equal to 30, and we see that the age is 30, and then the type of age is integer. Now I go ahead and right after that put age is equal to the string xyz, and I go ahead and print age and print type of age. So what do you think will be the output of this cell? So we had this age 30 before, but now we switch to XYZ. Should this print stick to this integer or should it switch? You can type your answers in the chat. I see string, I see str, string, I see char or character, XYZ. It will convert the string to numeric representation. I'll see another string. Great. Actually, yeah. I mean, um, I think I think it's really good that you participate in this. Give it some thought and see the result. This is a great way of learning. So yeah, I see another string. I see another XYZ class string. So basically, when we have this assignment here, and then we assign another data type, what happens in Python is that it completely overwrites it, right? So if I go ahead and run this, you'll see that now nothing about that integer value type is there anymore, right? So we just go ahead and remove it, and then now we have a new data type and a new value here, right? So this is how overwriting works in Python. So make sure if you have a variable, you don't use the same variable later in your code because it's going to overwrite the value, right? Now let me go with another overwriting example. So let's say we have a is equal to 5, right? Um, so here I put a is equal to a, b, c, d. Here I put a is equal to true. And then I again have a is equal to 10,000, right? So if I go ahead and print this a here and here and for all 4 items, so you can see that a begins with 5, but as soon as I override it with some string type value, it becomes a string, and then it becomes true, and then it becomes an integer again, right? So as soon as you use this equal sign, and then you put some value here, then you have basically overwritten your variable. All right. So with that, we are done with data types and variables. So I'm gonna quickly pause here again, go over this view, and let me take a look. Okay. So I see some answers in the Q&A section. So if for the interaction part of the class, then you want to answer the questions, if you can use the chat, that would help me better to make the distinguishment between Q&A and chat. So please provide the answers in chat and then your questions in Q&A. That would be great. All right. So I see a question here. Is there scoped variables? Um, so Aliona, do you want to provide? Okay, so I think it's answered now. Yeah, so I'm going to talk about those in the coming section for the blocks and if statement, if that's your question about. So so there's another question in the chat. The variable that changes type dynamically, does it end up pointing to a different reference every time? So the answer is yes, Yogesh. It does, and it's different from data type to other data type. And the way you can see that is basically through some command called ID, right? So if you add ID here, you'll see that the ID between these two is different. But this is a bit out of the context of this part. We'll see that. I don't think we'll see that today, but in some other lecture later, right? But from data type to data type, you're referring to some other ID for that variable. Yeah. So that's a great point, Bikram. So the range of variables is basically based on the type of integer that you define. So you can change the data type from, for example, integer with a specific number of bits to another type with different number of bits, and then you can see that the range will change. So basically, as you go outside this range, then it will be a circular effect that you'll go from the other end. So we'll see that later in the Python series. Um, so Rishi, answering your question about is every block on the notebook equivalent to a class? Not necessarily. So you can actually define a class within this block, right? So you can think about each cell of this notebook as a module, right? A part of the code that you can run independently, but then the variables would remain in the memories and you can use them before or after that cell. If you want to make sure that you remove the memory from all those variables, then you can go ahead and restart your kernel, right? All right. So I'm gonna now continue with the rest of the items here. All right. Let me pick up the option. All right. So now we have seen basics of Python and variables and data types. The last topic that we'll see before the first break is the operators and how to define operators in Python. And specifically, we're going to see arithmetic operators, logical operators, and comparisons. And we'll see some other components of each, but these are the main operators that you'll see. All right. So first will be arithmetic operations. Basically, mathematical operations between integers or other types of numbers. For example, the addition. This is how it works in Python. We just use the plus sign or the minus sign for subtraction. We will have multiplication using star. We have division using slash. And we also have floor division using double slash. So by floor division, we mean, the 10 divided by 3 will be 3 point something, right? So we find the floor of that number and we pick the integer part of it, right? And then we can also get the modulo, right? With the percentage sign. So 5 modulo 2. So 5 is basically 2 times 2 plus 1, right? So this 2 would come from this floor division, and this 1 comes from modulo, right? So in this example, 10 is equal to 3 times 3 plus 1. If you do the modulo here, it will give you 1, right? And then we also have the power, which we define with double stars. So 4 to the power of 2 is equal to 16. And this is how you should define it in Python, right? So one thing I wanted to note here before I go to the next slide is that these operators, the examples that are provided on this page, is mainly for mathematical operations and tweaks. But you will see that many of these can also be used for other data types as well. We can use them for strings. We can use them for Python lists. So we'll see examples of those as well. So now we want to take a look at comparisons. So we have the operators here in this column. So for example, this operator, which is for greater than, and it gives us a true if the left-hand operand is greater than the right-hand. So this is an example. So let's say we define x is equal to 4 and y is equal to 3. Then x greater than y means 4 greater than 3. And this is a true statement. So this basically gives us a true, right? Now, same way, we have less than, right? Which is true if the left operand is less than the right. So in this case, with the same example, 4 less than 3 gives us a false, right? So basically, if you take a new variable, let's say a is equal to x greater than y. Sorry. So you're defining a variable based on this comparison, right? So what happens in Python is that it's basically assigning true to a because this statement here is true. So we have two equal sign, which means equal to, and this becomes true if both operands on the both sides of this operator are equal. So the reason that we have two equal signs is that one equal sign, if you remember, was for assignment. So here, for example, in this example here, I assign some variable, some value to this a variable. So if I go ahead and write x equals to y, then because x and y are not equal, this is going to give us false, right? I hope this makes sense, but if it doesn't, don't worry about it. And we're going to see tons of examples after a couple of slides. Okay. So this was for equal values. If you want to check that two values are not equal, then this is the operator, exclamation mark and equal. So for example, x is not equal to y. In our case of this example, oops, right? In this example, x not equal to y is going to give us true because they're not equal, right? So this operator, greater than or equal, is very similar to this operator, but now we also consider the fact that they could be equal. So it's kind of a combination of this operator and this operator, right? Greater than or equal. So for example, 4 greater than or equal 4 is gonna give us true, right? And the same thing for less than or equal. So 3 less than or equal 3 is gonna give us true. So the other one is this operator is, right? And the other one is not. So this is how you use it in Python, right? So x is y and x is not y. So the difference between this way of defining it and this way is that basically here in this case we are looking at the reference point in memory. So I won't get into the details of that here, but just know that we have these operators existing with these operators, and we use this one in today's lecture. But if you want to check that they're referring to the same point in memory, then probably this is the way you want to go. But there's no need to worry about that. All right, and the last set of operators that we see are logical operators. So they're and, or, and not. So you may have seen these before in other formats, in other languages. Sometimes, for example, you may see and this way, or you may see and with two ands, or in this way, or two bars, right? So in Python, you simply write and simply write or. And this is why I mentioned in the beginning of the class that this is as close to English as get for a programming language. So logical and basically is when you want to, I mean, both of these operators are when you want to have multiple conditions, right? So when you want to check for 2 or 3 or even more conditions, you will add this and check that if both x and y are true. So if x is true and y is true, then this becomes true, right? So true if both of these are true. As soon as one of these gets false, then this becomes false, right? So if false and true, you'll get a false. But or is not that way. So logical or is true if either of the operands is true. So it means that even if one of these is true, for example, if this is true, x is true, or and y is false, or gets this true and doesn't care that the other variable is false, and it passes it true to the output. If both of these variables are false, then we'll get a false in the output. So x or y. So we only need one of them to be true. And not is only a negation operator. So it's true if the operand is false. So it basically looks at the opposite value of whatever we have here. If x is true, not of x is false. If x is false, not of x is true. So a couple notes here. We can have more than two, as I mentioned earlier. So you can have x and y and z, right? And you can have a combination of these. So you can have y and x or z, right? And you can simply just put a not here and have the negate of this and y. So you can play with this in so many different ways, right? Based on your application. All right. So yeah, so it's time to see some code now. Okay. So let me bring up the codes I have for operators. All right. So let's begin with some examples for arithmetic operators, right? So let's say we assign 9 to variable A and we assign 4 to variable B, right? So I run this cell because there is no print. When I run this, you don't see anything in the output. Now, in the next cell, I'm going to place this. So I'm going to say print. I will put a string. And inside that string, I write addition column. And then there's a comma, and then 9 plus 4, right? So basically, so let me do this. I go with A plus B because I wanted to show the assignment here. Okay. So what happens here is that it looks for whatever is inside the print. It goes with the first one and prints addition, but it realizes that, oh, I have another argument here, which is A plus B. So it computes this addition and then places it right after that print, right? So if I run this, you will see that. So now we can do the same thing with uh, subtraction, right? So it goes with subtraction is equal to A minus B, which is 9 minus 4, 5, right? So we can do the same thing for multiplication. I'll do multiplication, and then here we will need a star, right? And it says multiplication is equal to 36. Let's try division, which should go with slash. So as you can see, one single slash gives us 2.25, which is a float, right? Now let's try floor division. So let's go with the same thing and try floor division with two slash or double slash. If I run this, you'll get only the integer part of it. So you'll get the floor of the value, right? And what happens if we do modulo, right? Let me do modulo here with percent sign. you'll get 1, right? Because 9 divided by 4 gives you a modulo of 1. And this is one thing I really like about commenting. So you can add comments to make sure that you have the flow in your mind. So for example, I wanted to write here 9 is equal to 4 times 2. Maybe I can add star 4 times plus 1, right? So then this is showing me that the 4 division is 2, and then the modulo is 1. And then one last thing I wanted to show you was what happens to power. So power and double star is how you define power, right? So a power b means 9 to the power of 4. It should be a large number. It's 65, 61. So let's see another example to make sure it's working. So let's say 2 to the power of 3, which should be 8. Yeah. All right. So these were some arithmetic um, operators. Let me go ahead and try another one. Okay, so let's make this one a bit more interactive. So I'm gonna define a equals to 10, right? I will run this cell. I'm gonna add a few cells afterwards, and I want you to tell me what is the output of each of these one by one. So before you go ahead with your answers, you may realize that you see one new notation here: plus equals, minus equals, or star equals, right? So basically, this is saying that um, so plus equals is oops, is equals something plus something, right? So for example, let me give you an example so that we can learn better. So if you say a plus equal 1, this is basically saying a, keep the previous value of a, add 1 to it, and assign it to the same variable a, right? So if you have seen C++, for example, you may have seen a++ is an increment of this variable upwards. But yeah, never mind. So this is how it works, and it works for all other operators as well. So let's see what you think. You can add your answers in the chat. So you go one by one from here. What does the output of this cell shows? What does this one show? What does this one, and this one? You should give me five answers. All right, so we have 10, 20, 30, 20, 200, 10, 20, 30. Yeah, so I think we are getting to some consensus here. 200. 20. Yeah, so I understand that. So we have 10, 20, 21, and 100. So we have two different answers so far. 10, 20, 30, 20, 200 again. Mm-hmm. Yeah, I wait. I give it a few more seconds so that if anyone wants to participate. So we have 20, 30, 20, 200, and I think the first one is missing, which we'll see what it will be. Um, so I see a 200 for the last part. So I think we have a winner here of the answers, and that is 10, 20, 30, 20, 200. But let's go over this and see. So I think we had two different answers to this. So let's go ahead to see what will be one by one. So I run this a equal to 10. So let me go ahead and print this one as well. So now we know that a is equal to 10, right? Um, so we assign a to b, right? So now whatever inside a will also be assigned to b. But this doesn't mean that we lose the information on a, right? So if I go ahead and run this, you'll see that b is equal to 10. But if I go ahead and again print a, it doesn't lose its value, right? So it's still there. And you can very well have other values assigned. For example, c equals to a, c equals to b, and then you'll see that you're just passing these variables to other variables, right? So these are also 10. So now b is equal to 10, right? So the first answer was 10. The second one is saying that go ahead, look for the value of b, add 10 to it, and then put it back inside b. So basically whatever b was, which was 10, add 10 to it, right? And it becomes 20. And then you'll have b is equal to 20. So the second answer is 20. Now, we know that b is 20. So if we go ahead and add 10 to it again, it should become 30, right? So make sure that you don't confuse this plus equal with an assignment. So it is not 10 anymore. It should be whatever it was plus 10, right? So the third answer is 30. So now we know that b is 30, and we want to, subtract the value of a from the new value. So a was what? It was 10. So now this should give us 30, the current b value minus 10, the a value, which should be 20, right? And then same thing with multiplication. So the current value of b from here, we see that is 20. And then we want to multiply it by the current value of a. The current value of a hasn't changed. It's still 10. And then this should give us 20 times 10, which is 200. So yeah, so great job for those who answered correctly. But I really want everyone to participate, even if you have not correct answers to this. I think this is the best way to learn. Um, I mean, no one is here to judge you. I really appreciate if you can all participate and provide your answers. Doesn't matter if it's correct or incorrect. It's just an engagement with the class and trying to learn it on the fly, right? All right, so let's go to the next one. Now I'm going to provide some examples on um, comparison operators, right? So I'm going to put everything in one single block here, right? So this is the new block. Now I want you to go ahead and write 6 answers to this in the output, that what this piece of code here gives us. So your output should give us 6 integers. You can just put it in one line, or you can separate it by comma or something, or you can put it one after the other. Just I'll give it a couple of minutes for you to provide your answers. If you can provide the answer in one go, then that would be great. And maybe I can just put X here and mix here. So this may be less confusing. So we have true, false, false. Yeah, so I know multi-line is hard to do here. Probably you can add it with Shift Enter, but you can also add them in one line, separated by commas. True, false. Okay, so I see some different answer here. So I see uh, true, false, true, false, true, false, and I see true, false, true, false, 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 and yeah. So I see false, false, true, true, false, true. So now we have multiple answers this time. So we have true, false, true, false, true, false a couple times. For true, false, false. I see, and make sure there should be 6 in your answer. True, false, true, false, true, false, true, false. Okay, so I think one uh, point of difference between the answers is this one, which makes probably this a little bit tricky. Um, this has to be checked. True, false, true, false, true, false. Okay. I think there is one predominant answer that I'm seeing, but there are a couple of these items which are probably a little bit controversial, and I'm seeing some different answers. So I'm gonna give it a couple more seconds to see if anyone wants to give it a shot. All right. Thank you everyone for your participation again. Oh, I see one more answer: true, false, true, false, true, true. So basically, these also need to be checked. I think there was a couple of them which I saw some different answers. These last three. Oh, another one. False, true, false, true, false, true. Um, or maybe there's a additional false in the beginning. I'm not sure. False, true, false. Okay, great, great. No, thank you everyone for giving this a shot. Oh, okay. There was a great. Um, so it's great that you fixed it three. But let me go over the solution and see um, what each one of these give us. So a is equal to 13 and b is equal to 20, right? So we are assigning two integers to these two variables, 13 for a and 20 for b. And we are defining x to be a greater than b, right? So this here should be a Boolean, right? It's either true or false. Now let's go over this one by one. So this first one is giving us a less than b, which is basically saying is a less than b. So this is true, right? So the first one should give us true. So the next one is saying is 13 equal to 20, right? So this is not true, right? The values are different, so this should give us a false. So the next one is giving us is 13 not equal to 20, right? this is a true statement because 13 and 20 are two different variables, and this should be a true, right? So this is basically saying 13 greater than or equal to 20, right? So that is not true because 13 is strictly less than 20. So this should become false. How about this one? So 13 is less than or equal to 20, right? So this is true because 13 is strictly less than 20. So both of these two statements, less than 20 and less than or equal, should both be true. And then the last one is basically a variable defined in this way, which says A is greater than B, which we didn't have here. So it's basically saying 13 greater than 20, which is false, right? So basically what we are defining here is we're defining X is equal to false. So these two statements, X equal to A greater than B or X equal to false, these two are equivalent, right? So if I go ahead and run this, we will get this list of answers. True, false, true, false, true, false. I think this was the dominant answer I was seeing in the chat, but for those of you who didn't get this right, hopefully this now makes sense. But if it doesn't, please let us know in the chat. Okay. All right. So let me go over the last set of examples for the logical operator. I'm gonna add another exercise here. So I'm gonna define A, B, C, and D. And I want you to give me your answers to these 5 items. So we have A is set to true, B is set to false, C is A or B, and D is A and B. Now I want you to tell me what are each of these values, which will be shown in the output. Please go ahead and do this again in one line with comma separated. So we have false, true, false, true, false. So we have true, false, false, true. So we already have different answers, which is great. I mean, you should definitely try this. Okay, so let me take a look. So false, true, false, true, false. We have false, true, false, true, false again. Yeah, false, true, false, true, false. Okay, so I think we are again converging to one solution here. True, false, false. But I want everyone to participate. Yeah, I'll give it 1 more minute here. So we have an updated answer of false, true, false, false, false. False, true, false again. Okay. Any other guesses? We have false, true, false, true, false. Okay. So this is uh, another one, the same as the one before that. Okay, so we have another updated one. So no worries, Sri. I mean, it's great that you're trying this out. I really appreciate it. And yeah, I mean, this is the point of these assignments to, you know, if you get it wrong in the first place, then you go ahead and fix it, and that is great. All right, so I'm gonna go ahead and provide the solution. So we have A equals to true, B equals to false. So and was that logical operator which um, we needed to have both arguments equal to true so that we get a true. Now that one of them is false, right? We will get false here, right? So um, again, the way we defined or, because either of these could be true for this whole thing to be true, and we know that A is true, so this should give us a true. How about this? So whatever A is, when there is a not before that, then that should be the negation of that value. So if it's true, then it becomes false, right? So how about this one? So C is equal to A or B. Again, this is exactly as this line. So we could basically write print A or B or print C. So these two are exactly equivalent. So we just go ahead and write true. And here we have D is equal to A and B, and this is exactly equivalent to the first line. So we go ahead and write false here, and then if I run this, we should get the same result. All right. All right. So we have one last topic before our break, and that is the input function. So input function in Python is the way you can get inputs from the user. So let me go ahead and take my pen here. All right. So in Python, this is how you define it. So you will write inputs with parentheses and the prompt inside the parentheses. So this is how you collect input from the user. And this prompt here is a note to the user of your code um, to instruct them how to give us an input, right? This is optional. So this prompt parameter displayed to the user is optional, and you can simply ignore that or remove it, right? This is how you should define it in Python. We'll see the code in a minute. Um, so the way input function is designed in Python is to read strings. So input is always a string, right? But you can use typecasting to convert the input to some other values, such as integers or floats. So typecasting is something we will see shortly. But um, the point here is that you get some input from the user, and if the input you want it to be integers, then you can add an integer in this way. You have int some parentheses, and then the input to the user, the command should go here, right? And then you can assign it to some variable of your choice. So what are the best practices of using input function in Python? So first of all, make sure you provide clear instructions to the user of what type of values that your code is expecting. And you don't want your code to show errors if the input of the user is not a valid input, right? So then make sure that you're handling these kind of situations with some built-in designs in Python, which is exception errors, right? So this is how it should be defined in Python. So you try something, and if you get an error in whatever you try here, then you provide exception that, all right, so if there's an error of this type, right? So in this case, is a value error. Then if in that case, then print this out to the user, right? So in this case, you are prompting. So here's the prompt, right? So you're prompting a user to enter a number, and then you go ahead and convert to float, right? And then you put that inside inside this num variable. So let's say the user enters 2.3. This num captures that 2.3, and then you don't even go into the second part because there's no error in your code, right? Now, what if the user goes ahead and adds like uh, some name, a string? Then this part is gonna give you an error because float of name as a string doesn't mean anything. Then Python wouldn't show any error in the output, but it will show this piece of string to the user, which is invalid input. Please enter a valid number, right? So we'll see that in the code in a second. All right, so let's go over to the notebook again. All right, input function. What I'm gonna do, I'm gonna ask the user to type in their name. So input the prompt to the user to enter your name. Let me also add a column here. And I also want them to add their year of birth, right? And then what I will do is, because the year of birth is probably an integer, I will go ahead and put int around this thing. And I find their age as the current year minus their year of birth, right? So this is the arithmetic operations that we saw before. And in the output, I'm gonna print your name is equal to name, right? And then I'm gonna say your year of birth is equal to year of birth. And then we also say your age is equal to age, right? So let's see what happens when I run this cell. So first, it's prompting me that enter my name. So I will say, let's say we add some name, Sarah. And then enter your year of birth, which let's say we add 1995, for example. And then in the output, it gives us your name, Sarah, your year of birth is 1991, and then your age is 2023 minus 1991, which is 28. So as I mentioned before, if you have print without anything as argument inside it, it goes to the next line. So I'm going to add this and run it again to make sure the output looks better. And we have this space between our output and our input, right? All right. So one other quick example for reading numbers only. So I prompt the user to enter their first number and then their second number, and I put them into variables number 1 and number 2. And then I sum these two. Let me make sure sum of nums. So as you see, when you write sum only, the color changes, right? The reason of that is that sum is a built-in Python function, right? Whenever you do sum of num1 plus num2, then you're overwriting that function and making it a variable. And this is not a good habit in programming because you may need this sum operator later in your code, but you have instructed Python to, I don't need sum at all. Go ahead and overwrite the sum with a variable of my choice. And basically, whenever you have sum in your code, then you just see that value. It becomes an integer, not an operator. And this is basically why this color coding exists in Python, right? So make sure that you follow these best practices, which will be really, effective in your way of coding. So sum of nums, and then I print out, I will say, the sum of these values is like this, right? And I want to also put a space between these two. So I run this one. So enter the first number, I'll add 3, enter. The second number, 5, enter. The sum of these two values is 8, right? Now, one last example. Let's see what happens with that try except thing that I mentioned. So how can we handle the error? So let's say in this example, we want to get a number from the user. It could be any number. It could be float or not float. You will see that even if we add an integer here, this piece of code interprets it as a float. So this is called implicit typecasting, and we'll see that later today. But if the user comes with some weird input, such as a string, then we go to this except part. So we'll go ahead and print invalid input, please enter a valid number, right? And then finally, we're going to go ahead and print that number, right? So let me add a print here as well. So the first trial, I will go ahead and add actually a number, a valid number here. I will add 4. And as you can see, in the output, you will get 4.0, which is the float type of that integer, right? So I run this again, and I add 2.3, right? And then we will get 2.3 in the output, right? But now I'm going to run this again and write, today we are having Python class, right? Just a random string. I press on enter, and then as you can see, it says invalid input, please enter a valid number. So one thing is that you also see that we'll get 2.3 here, and the reason is that this number that we got from the last iteration is now in the memory, right? So it still goes ahead and print that number. And this was maybe my mistake of adding this at this part of the code. So I will go ahead and add this printing inside this block. So probably one thing you may wonder is that this is the first time you're seeing these kind of code here, that we have try, colon, and then we go 4 spaces with some code, and then except, then 4 spaces with some code. This is the indentation I was talking about. So in Python, this space right here is how the code understands that we are trying it, right? And then you go ahead and remove that indentation for except, because this is now, we are basically instructing Python that this is continuation of that previous block, right? So if you go ahead and put an indentation here, what happens is you'll get this error that this except is an invalid syntax because the indentation doesn't work, right? So we move it back. One other thing I wanted to show you was, let's say we don't have this try and except format. So right now, um, if I put a string here, A, B, C, D, it's going to give us invalid input, please enter a valid number, right? But what if we don't have this thing? So I'm going to go ahead, comment this part out, and then remove the indentation here. So again, the short keys for commenting is control and slash. As you can see, I'm not writing anything. I'm just pressing on control and slash at the same time. And then the short key for indentation is just choose the line you want to indent, do the indentation, and then press on tab. And if you want to go back one step, it's shift and tab together, right? So I press on control enter, and I will say A, B, C, D, and then I'll get this error saying that there's a value error. I could not convert a string to float, right? So this string that we're adding here cannot be a float, which is trying to convert to by typecasting. So we'll see a lot more about typecasting and what this really means to think about float as a function. But for now, just let's go with the fact that this is trying to turn the user's input to a float. So I'll go ahead and turn this back to what it was, and then one good example, for example, 3.4, right? All right. So let's see quickly the typecasting that I mentioned, and then we'll get a 15 minutes break. Okay. All right. Let me go to the full page view. So typecasting in Python is basically, as I mentioned, um, the process of converting one data type to the other data type. And it's really important to have a good grasp of typecasting because it's essential when you want to make sure that you have consistency in your data. When the input from the user or even the variables that you define by yourself in your code are in different types, right? So, for example, you have some integer, and then you have a piece of string, and then you want to make sure that when you're bringing in any operator, you're not gonna get into any issues. So let me give you a very quick example here on what I mean. So let's say, and this is some example I've seen probably on a daily basis in my own work. So let's say you define you have users in your system, and you have a user ID, right? And this user ID comes usually in the form of a string, and it's a long, numbers, something like 00021058923, something like this, right? And then for any reason, you may want to put this in a table, right? And one of the columns of this table, so your table has multiple columns, right? And each of these columns has a name, and this part is the user ID, and there could be some other attributes in these columns, right? So for any reason, you may want to switch this long number to some other short number, or if you want to, hash this to some other value. For any reason, you may want to pass in the integer form of this value. That's where you need typecasting to make sure that the code that is converting this understands that this is now an integer, not a string, right? So if you don't handle this correctly, then you'll get into errors, and then you never want to have that when your code is into production. So you want to make sure that you handle these kind of um, data type conversions beforehand. So yeah, as I mentioned, typecasting can help to avoid type errors. For parsing the user input, we saw examples, and then we can convert between numeric and string data as we saw in this example, right? So now, what are the different types of typecasting? One is implicit and one is explicit. So implicit is when Python inherently kind of understands what is the data type. So for example, you have an integer value, like you have here, you assign 5, right? And then you have a float value, which is 2.0. When you add up these two values here, Python understands that these two are numbers, and probably 5 can also be considered as 5.0, and then it outputs the result in a float format. So this is called implicit typecasting. Implicitly, integer value is typecast into a float. And another example, you have an integer here, 3, and you have a complex value, 4 plus 5j. So for those of you who don't know complex values are basically those numbers which have a real part and an imaginary part. And this is all you need to know for this example. So basically here, the 4 is the real part, 5 is the imaginary part, which will be accompanied by j beside it. And you can try this in Python, it works. So when you multiply these two, Python realizes that you're multiplying probably a real number to some complex number, and the final value would be some complex number where this 3 is multiplied by both real part and imaginary part, right? So that was implicit typecasting. So explicit typecasting is when it's not straightforward for the code to understand what is the data type, what is the value, and you, who owns the code, go ahead and instruct the code to convert this to an integer or a float or a string or other types of data types like lists and tuples that we'll see later in today's class and week 2 of Python fundamentals. So for example, if you define a value and assign 42 to it, and you want to make it into a string, you go ahead and put a str, in parentheses, you add this value, right? And then this is what you get in the output. You probably won't see the difference in the output, as we will see in the code in a bit, but it is switched to a string anyway. So some common use cases, reading numeric input from user is one very important use case of typecasting. And also, if you want to perform calculation where there are different data types, that is also an important use case of typecasting. All right. So let's go and see some code. You have typecasting here, and I'm gonna open up my notes. All right. So a couple quick examples and then one exercise, and then that will do it. So the first example is, let's assign this string, which is 25, to age. And this can very well happen in many cases when you're working with real data out there. Um, and there could be reasons behind it, and I'm not going to go into the details of that. But the main reason is that there are so many, um, hashing happening in the backend to make sure that data storage is efficient. and consistent. So this is why you may see age will be added as a string, for example. But we don't want that as a string in our own code. We want it to be an integer. So we do a typecasting, in this case, explicit typecasting. And now we have this integer, but age, but in an integer format, right? So we want to print the integer age and its type. Let's also add one more thing. So I'm going to have a space between the two. And we want to see the string age. So what was the original? And the type was this, right? So let's see what each of these give us. So as you can see, it says the age is 25. And here also says the age, let's go ahead and remove this. It also says the age is 25. So both of these are giving us the age is 25, right? But we know that this first one is an integer and the second one is a string, right? So let me tell you something it may be good to know at this point. So later we will see that you can add to strings by using the addition operator, right? So what happens if I print this plus some string, and then you will get exactly the same thing, but probably I need to add one space here. So this is the same thing that we will get, right? So we'll get this string and the original string, and it will be combined together. So what happens if I add that plus sign here? Because now int age is an integer type of that original age. So we will get this error, which says that can only concatenate or append string to string, not integer to string, right? So it's very important if you have some stuff like this in your code, and then you forget about typecasting, you may run into these kind of problems, right? So I go back and put a comma here, go back and put a comma here. So these two answers are the same. The first one has a class of integers and the second one class of strings, right? So another case here. So now this time we define age to be 25, but in characters, right? And we want to make this into an integer. What do you think will happen? So we are actually asking Python to get this string and give us its integer, right? But this is not what Python uh, knows as integer, right? It only gets digits for integers. So if I go ahead and run this, it gives us this error at this line saying that there's a value error, invalid literal for integer function with base 10, 25. So basically it's saying that 25 is not an integer. I cannot convert that to an integer, right? All right. So let's go ahead and see a couple of implicit typecasting. So I'm going to put this here, put this one here, and I'm going to put this one here, right? So what I want you to do is that for these three cells, right, only give me the result of this first print, right? So the second print is the type, forget about it in your answer. So only for the first print, addition here, and convert it to string. Only for these three lines, give me your answers. What will this print function display in the output? Um, so you can also skip this first part, addition converted to string. You can just give me the result, and the string value. Okay. So I see converted to string 42. Yeah. So it would be great, Justin, if you can give me all three answers. So this is the answer to the last one, if I'm correct. I see that there is 7.0, 12 plus 15J, and I also see 42. Um, I see 7.0 addition and type floats. I see 10.0 for this one, and 12 plus 15J for this one, and 42 for this one as a string. I see a 7 here, an error for this one, and a 42 for this one. So basically, um, uh, this is giving us error from what I see in the answer. So one, we have 7.0 float for this one. We have 7.0, 12 plus 15, 42. We have error 42. We have 7 plus 5J for this one. Um, and let's see other answers. So we have 7 plus 5J. So let me go ahead and write these answers. So some of them are really good to have here. So we have um, one answer was 12 plus 15J. And I see another answer giving us 7 plus 5J. I see another answer giving us an error. 12 plus 15J. 12 plus 15J. For this one, we are getting 7.0. We are getting error. We are getting 10. Was it 10 or 10.0? Or maybe I was wrong. I don't see that. So, and for the last one, the answers that I see is 42. It's 42. What else? So we have 42 again. Anyone says it gives us an error? I don't see anything here. What is, so we have a question, what is J? I tried changing it to something else and kept receiving an error. So J is what that makes this number a complex number. So if you, J is actually pre-built in Python to make sure this is how you define a complex value. If you change J to anything else, then it doesn't work. If you also assign a value to J, it doesn't work as well. So you shouldn't assign any value to J if you want this to work. All right, so let's go ahead and see what are the results of each of these. So, and again, thank you all for participating. Um, it's great to know all the answers so that we have some idea why these kind of answers, what could result in these answers, and make sure that we prevent if any of these are wrong. So for the first one, we get an integer value of 5, and we get a float value of 2.0. So the result adds these two values up. I see a new result answer again, 7.0, 12, and 42. Okay, so let's see if that is correct or not. So this is one example of implicit typecasting, right? Because we're not specifying what these are, and then we rely on Python to understand what is the result of adding 2.0 and 5. And what Python does in this case, it looks at these two and say, all right, so we have 5, we have 2.0, probably this is 5.0 as well, and then I sum them up and show 7.0 as the output, right? So this is one example of implicit typecasting, and the type of the output will be float. Now, for the second example, so the integer value is 3, and the complex value is 4 plus 5j. So when we do this multiplication, this is again an implicit typecasting in Python, where it looks at this thing here and realizes that, all right, so probably I'm considering a complex value here as well, which has 3 plus 0j, and I'm multiplying this to complex value and show that to the user. But because this doesn't work, we don't have this part, we go ahead and just multiply this real part by this real part, this real part by this imaginary part, which will give me 12, which is 3 times 4, and 15, which is 3 times 5, and show that to the user, right? And this is a new class that we're seeing here, which is complex numbers, right? Yeah, no worries. So this is a star sign. It was not a plus sign. Maybe I should have made that clear in the beginning, but it's totally fine. It's just an exercise. No worries if you got the not the correct answer. So the last one, I think people who mentioned 42 meant 42 as a string, because in the output you don't see 42 as a string. But anyways, let's look into it. So the value is 42 as an integer, and the string value is the same value typecast as a string, right? So now if you look at the output, we're going to see that 42, and then the class, the type of that variable will be string, right? All right, great job, everyone. So let me go back to the slide. Okay, so now we are done with the first 3 parts of Python Basic. We're gonna have a break now, but before that, let me look into the Q&A and see if there's any unanswered questions here. So I see one from the previous topic, which says I created 2 variables A and C with values of 5 and use is, and it gave me true. Should not be false given that they are 2 different variables. So let me go ahead and try this here. So basically the question is, you have A is equal to 5 and C is equal to 5, right? And you have A is C, right? So if you run this, it's going to give you true. So it gives you true because in case of integers, when you have 2 integers in the right range, they're going to refer to the same ID, right? If I go ahead and say print ID of A and ID of C, let me go ahead and print this below so that it don't get confusing. So as we can see, the IDs of these two are the same. And this is why you're seeing the true. But let's not go into the details of that. We're going to see these references, the IDs later in this Python series. But that was a good question, Adrian. Thanks for thank you for asking this question. Hope this answers your question. So I see another question here saying, why is this true? So I'm gonna put it here. So I'm gonna say x is equal to 5, y is equal to 3 plus 2, print x is y. So the question is, why is this giving us true? because x is 5, 3 plus 2 is 5, right? So it's the same integer. This is an arithmetic operator. It gives us 5. And then because what we've seen in the previous question, this is going to give us true, right? But again, let's keep it to this for now. Thank you for the question. And then, so the last question I see here is saying that why a string 42 in the output is not 42 as code. So as you can see, Nandini, it's giving us 42 when it's printed out alone in quotes, right? But if you add some string before that, let's say the number is, right? Oops, sorry. This was a string of 42. Let me go over that again. I think I messed up something. So if we do a string 42, string 42, it's going to show you in single quotes, right? But if you add some string before that, decoding string, sorry, there's no string here, right? And then I put print instead. Then it's going to show you the number is 42. There's no quotes here because now it's considering this entire thing as one string, right? So that's where you don't see those quotes. But if you print string 42 standalone, then it gives you the single quote. So what happens if you add print here? If you add print, it again considers it as a full string. So it drops the quote. Yeah, but this is nothing to worry about really. This is just how this editor works, right? So you just need to make sure that you don't get this confused with integer type 42 when you see it in the output. Great question. So I'm gonna go ahead and remove these things from this section. Okay, so with that, I think we have answers to the questions. A couple of things I see in the chat, but let's go ahead and start the break. I'll go over just questions in a few minutes. So yeah, let's go ahead and get back here in 15 minutes. All right. So let's continue here. Hope everyone is back. So there was a question in the chat that will the slides that will be shared after and the worksheet and after the class. So I've reached out to the organizers, and I want to make sure that we can reach the resources with you after this class. So I'll get back to you on that one. All right. So let me go back one slide here. All right. So then how about my input pad? All right. So far we have seen some basics of Python, the concept, the variables and data types, operators, arithmetic operators, logical comparisons, and we also saw some, typecasting, the input function. Now we're gonna use all that, all we saw in the first part, and then use them in the if and else statements or conditional statement, and then loops and functions, right? So these are extremely important components of every Python code. And then you'll see how much application they can have in a very, very small code as well. So let's go over to Python if and else statements. Um, so conditional statements allow branching in the code based on different conditions, right? So you're basically branching your code in the sense that at this point of the code, based on whatever logic I have so far, is this true or not? So if that condition is true, then we go to this branch. If it's not true, I take another turn, right? So um, the way you can do that in Python is through these syntax commands: if, else, and elif, which is basically the same as else if, but in Python we show it with elif, right? So these are the main, most important keywords for if else conditions. So again, going back to indentation, you probably have seen this indentation comment multiple times so far because it's very important in Python programming. So, for example, you may have seen in other programming languages that when you open up a curly brace and then you close it, then whatever you do here with or without indentation doesn't really matter, right? But in Python, you don't have these curly braces, and the only way that the code understands that you're within this code block is with that indentation of the code where you have this code and then you have the indentation, then you cut back so that this block is finished now, right? So again, Python uses indentation to identify the codes for if and else statements. And this is the same for loops and functions, right? So whatever we see in this section of the lecture, indentation is extremely important. So as I mentioned earlier, again, the best practice is that keep your indentation consistent throughout the code. If you're using one space, just keep with that. If you're using one tab or 3 or 4 spaces, just make sure your code is consistent with the same spacing. So whatever we learn from logical operators and or not, um, we can use all of them to create complex conditions. So we can have multiple conditions with and or we can have some condition and then negate it with not, right? So we'll see all of that in a code a bit. And we can also have nesting in if and else statements, which means that you can have a condition within a condition. So we also see example of that, but nesting of if and else statements and loops is actually very important and happens when you have multiple branching or multiple loops within another loop that you want to implement in your code. We'll see all that in a bit. So some best practices for if and else statement. So make sure that the conditions that you have in your statement is simple and readable. And this is not just for if else statement. So always try to make sure that if you're adding a condition, you make it as simple as possible and as readable as possible. So the variables you choose, the way you put it in your if and else statement. So these are all best practices to make your code readable and reusable for future if someone wants to make use of your code. So you can use parentheses for clarity when combining different conditions. So for example, you will see that if you have an if statement and you have some condition here and you want to add some other condition, right? And then you'll have colon to say if this happens, then what we have to do. Then it would be great if you can add a parenthesis here for each condition to make sure that we are separating these conditions from each other, right? All right, time for some code here. Let me bring back my keyboard. All right, so if else statement. again, we see some examples, and then there will be a couple exercises. So the first thing is, let's say we have an example of voting eligibility. So we want to see that someone is eligible to vote or not before or after the age of 18. So we say that this boy or girl has just got 18, and we want to let them know as soon as they get into the system, we want to let them know if they can vote or not. So this is how we define this control, the conditional statement. As you can see here on this slide, if condition, then you will have a block of code if condition is true. If that condition is false, then you go to else. And then the block of code, you know, whatever you have here in this block of code will run. So if you have multiple of these, then you have if condition 1, then whatever inside it, else if another condition, whatever code inside it, else, then whatever else, if those two conditions are wrong. So here in this code, we're saying that we assign 18 to age. If age is greater than or equal to that number, um, then this number, which is 18 here as well, we will print you're eligible to vote. If this is not true, then we will print you are not eligible to vote, right? So if I go ahead and run this, it says you are eligible to vote because 18 is greater or equal than 18 because these two are equal, right? Sorry, let me go ahead and, okay. Now, if age was 20, right? Again, age is greater than 18, right? So if I run this, you're eligible to vote. But if age was, let's say, 16, then it says you're not eligible to vote because it looks at this condition. This condition is false because 16 is not greater than 18. Then we go to else and we print out you're not eligible to vote. Okay. Now let's see another example. So we want to see if a given integer is even or odd, right? Oops, sorry, I didn't want to run this cell. But anyways, okay, so let's go over this. So we assign this number to variable a. So 13 in this case is an odd number. So what does it mean for a number to be odd? It means that if we divide it by 2, the modulo will be 1, right? So let's see some examples here. So let's consider 6, for example. So 6 is 2 times 3 plus 0, right? So there's no remainder. Or um, if you find 6 modulo 2, you'll get 0, right? But if you do this for 7, right? So 7 is 2 times 3 plus 1. And this gives us 7 modulo 2 is equal to 1, right? So this is very important to know that whenever you want to check if a number is even or odd, you will find the modulo with 2. If it's a 0, it's even. If it's 1, it is an odd number, right? So I will put even here and I put odd here. So here in this code, we are saying that if the given integer modulo 2 is 0, basically if the given integer is even, then print out even and print do something, right? I don't know why this is here. So I'm gonna remove that. But if that is not the case, if this condition is not true, which means that if a modulo 2 is not equal to 0, and in this case will be equal to 1, right? Then we will print odd, right? So one thing we can do, we can see that, for example, also what happens if we divide a by 2. So let's print this as well, right? So when we want to do something both in if and also else, then because it happens both places, then we can bring it outside, right? So I can bring this, remove the indentation and remove it from both. So this basically runs this part of the code. Whatever happens, print the division by 2, right? So in this case, I run it. It says a, and I'm gonna bring a here. A is equal to 13, so it is odd. We go here, this is false. We go to the else part of the conditional statement, it prints out odd. But anyways, because there's no indentation, this is the main body of the code, it prints a divided by 2, which gives us 6.5, which is a float, right? Now let's see what happens if I have the a is equal to 6. It says it's even, and 6 divided by 2 gives us 3.0, right? So if I have another slash here, then it gives us 3 as an integer because it was a floor division. But if there's only one slash, it gives us float. All right. Now, let's see one more example of if and else and elif conditioning. So here we're saying that we are given a number assigned to 7. If the number is greater than 0, which also means if the number is positive, print is a positive number and we are inside the if block, right? If the number is less than 0, which means negative, then we will say this is a negative number, and then we are inside elif block, right? And then none of these two happen. What does it mean? It means that the only option is that we are at 0, and it says print 0, and we are inside the else block, right? And this will get printed outside if outside conditional statements, right? And these should print out anyways because we're not inside any of these blocks. We don't care about these conditions anymore. This is outside of that, and we should see that on the display. So let's try a couple numbers here. So if number is 7, then this is positive. Then basically we expect this part of the code to run. So it says positive number inside if block, and this runs anyway because this is outside conditional statements, right? So I'm gonna go ahead and add one more print here so that it looks better in the display, right? So I'm gonna add -5, right? So this is a negative number. So I'm assuming that it passes the first one because this statement is false. And then because this is true, we go inside this elif and we display negative number inside elif block. And this, again, will be displayed anyway because we're outside this part, right? And what happens if we have 0 here? So you can see that none of these two are true. So we'll have 0 inside the else block, right? So we are inside the else block. All right. So now I'm going to give you a multi-condition exercise. Let me bring that here. So let me add a couple things here. So this is example 4. And this is example 5. I'm going to give you a few minutes to think about these two examples and tell me for this given age in the first example and has license true, what is the output? And for this example, for number 14, what will be the output? So to post that in the chat, you can simply have shift and enter so that you can go to the next line without entering your final answer. And please add that to the chat, not the Q&A, so that we can have all the answers in one place. So let's keep Q&A for the questions that you may have. All right, so I see um, a few responses here. So I see you're allowed to drive for the first one. So I see you're allowed, you're allowed. Oh, that's okay. Justin, please just have answers separately. That should work as well. Um, you're allowed to drive an even number which is greater than or equal to 10. Same here, greater than or equal to 10. You're allowed to drive an even number greater than or equal to 10. Yeah, seems like we have consensus here among the answers. I haven't seen any different answers yet, really. Okay, cool. All right, so I see that most people are aligned with the same answers. So I'm checking both Q&A and chat. Okay, so great. Thank you for your answers. Yeah, you're allowed to drive an even number greater than or equal to 10 again. So let's see why this is the case. So in example 4, we have age is equal to 25 and has license equal to true. Now we have 3 conditions to check, but each of them have multiple conditions, right? So if these 2 conditions both exist, and actually I told you that the best practice is to add parentheses here, but I didn't myself. So let me go ahead and add those parentheses. So this will make sure that, I mean, it works, but probably having these in parentheses, will be, make it look better and more readable, right? So this is saying if 8 is greater than 18, greater than or equal 18, which is the case here, and has license, and has license, these need to be true or false. So basically it looks at this value and it's true. So both of these are true, then we go inside this condition and we should get this answer, right? So you're allowed to drive. If I go ahead and run this, you're allowed to drive. So if I go ahead and instead of 25, I have 17 here. None of these two work because the first condition is not met. And then we go to this else statement, which gives us you're not old enough to drive. And then if we have this to be 25, but this has license is false, then this is not true because the second condition is not true. This is true because both of the conditions are true. And this is the negation of a false, which is true. So it goes ahead and prints out, you need a license to drive. So how about the next example? The next example is, defining a number integer in num equals to 14. So you look at this condition first. So if the number is greater than 10, which is in this case, we go inside this block. If it wasn't the case, we would go here. So now that we go in the first block, if the number is even, which means if the modulo is equal to 0 with 2, modulo with 2 is equal to 0, then we will print out this statement. If not, we will do that for this statement, right? So in this case, because 14 is an even number, we go to the first block within this block. So it prints out an even number which is greater than or equal to 10. So let's say number was 13, then here this wouldn't be satisfied, so we will probably go to else, right? So an odd number which is greater than or equal to 10. So if this was a 7, which is not greater than 10, but it's actually smaller than 10, then you will have an odd number which is less than 10, right? So it's here. All right. So I see a question in the chat that how can we represent infinity? So to represent infinity, you probably want to use the NumPy package in Python, or just simply use a very large number. So NumPy is something that we will not cover today, but on the 4th week of Python fundamentals. But for now, if you just want to use a very large number, you can just go ahead and add a large number in your code, and that should work. All right. So now we know about if and else statements. Now let's see how loops work. So we have two types of loops: for loop and a while loop. The for loop is to iterate over a sequence, and usually the sequences are defined in a Python list, tuple, or string, and all of these data types we will see. Two of them we'll see today. Yes, so lists and strings we'll see today. Tuples, dictionaries, and sets we'll see on the second week. But while loop is actually not necessarily, we could also do a sequencing with while loop, but the main difference between these two is that while loop occurs, whatever we see inside the while loop occurs while a condition is satisfied. As soon as we violate that condition, then we get out of the while loop. For loop doesn't care about any violation. It just goes through that sequence until it's finished. Unless we want them to finish, we force them to finish that iteration at some point, which it's called the control loop control that we'll see in a couple of slides. So this is how we define for loops. We'll see in the code in a minute. So you'll just have your for or while written here, and then you will add the index to be inside some sequence that you can iterate through. In this case, a range of 5 is giving us a sequence of 0, 1 to 4, right? So it excludes the last element. But in case of while, so we have a condition here, right, which is giving us this counter to be less than 5, which means as long as counter is less than 5, I do whatever you see here. So if you forget to, so let's go first to the first line. So while counter is less than 5, you will print this while loop iteration shows the counter, and then you increment the counter in each iteration in this loop. So if you forget to increment the counter, then it goes on and on forever, right? So this is something which could be tricky for while loops. So for loops takes care of this inherently, but the while loop, you need to make sure that you have this counter in place. And so we have control statements for the loops, which I mentioned on the previous slide. So for each of the for loop and while loop, we can have break and continue. So break kind of enforces exit from the loop immediately. So as soon as you get to a point that you hit break on a for loop or a while loop, you get out of that loop, right? As soon as you hit a continue, though, you won't get out of that loop, but you will skip one iteration and go to the next iteration, right? All right. So I'm gonna go ahead and switch back to the code again. And I'm gonna take a look at the notes here. Right. So let's go over the syntax together. Um, so again, we'll have for or while. Then just looking at for now, we'll add the index for the iterator. And we want it to be in the range of 5, right? So let's see what does range of 5 give us. So range of 5. So range of 5 is basically an object which gives us the range from 0 to 5. And this excludes the last element. So it goes from 0, 1, 2, 3 to 4, right? So later you will see that we can pass this to a Python list. But just to give you what's inside that object, it's 0, 1, 2, 3, 4, right? So this is basically what happens here. So for I in that range from 0 to 4 inclusive, print I and also print hello world in the same line, right? So let's see the output of this one. So we go from 0 to 4, we have 0 hello world, 1 hello world, so on and so forth until 1 minus 5. I mean, one iteration less than 5, right? But we can, we don't need to start from 0 necessarily in the for loop. So we can have the same code here, but instead of starting from 0, we start from 1, right? So the default when you don't assign any number, right, is that it starts from 0. But I'm gonna assign 1 here, right? 1 to 5. And the output will be 1, 2, 3, 4. So the other thing that I'm going to show you, but we will also see that uh, later today, is the steps that we can skip some of the iterations. So for example, I added 2 here. It basically says, all right, I'm going to start from 1. I go all the way to 5 exclusive, but I will jump every other iteration. So I have 1, I skip 2, I have 3, I skip 4, and 4 is the last one. So that's it, right? So this is what this step size 2 does, right? So let's see an example of how we can use a for loop. So again, I'm gonna, instead of sum, I'm gonna write sum of values is equal to 0. And I want to add all the numbers from 1 to 100 and see what is that sum, right? So I say for x in the range of 1, 2, 3, 4 up to 100, right? I have sum of values is equal to sum of values plus this x. So we start from 0, and then each time I go ahead and add that number, right? So if I go ahead and print this, sorry, I have to add a print sum of values at the end, right? So if I print this, then we will have 50, 50, which is the sum of all these values. So if I go ahead and reduce this to 5, It's basically giving us 1, 2, 3, 4, which sums up to 10, right? And actually, one thing I wanted to mention here, instead of equals sum of values plus x, we can also do plus equals to x, right? It should give us the same result. All right. Now, let's see another example with the strings. So we can do exactly what we did with the counter. We do it with a null message. And then from 1 to 10, we want to have that message add up with those numbers, right? So we turn them into strings. So this is explicit typecasting that we saw. And then I'm going to go ahead and put this print out of this for loop. And then this is giving us 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So 10 is not included. So what happens if I put print inside for? So each iteration, as soon as you add one of those digits, you will see that in the output, because now print is a part of for. This is why indentation is so important in Python, right? I can also go ahead and add, what I can do is I can add a space here so that we can have this space between the digits. All right. Now let's try one example for while loop in this case. So we have a counter set equal to 1, right? So while count is less than or equal to 5, right? So we print hello, and then we add up count with 1, right? So we increment that with one step. So this basically is saying that print hello for me 5 times, right? So it prints hello 5 times, and then at the end, the count is equal to 6, right? So because 6 is not less than 5, we got out of this while loop. So as long as 6 was less than or equal to 5, we printed hello. So as soon as it got to 6, this was false. So we get out of the while loop, and then we see that counter is now equal to 6, right? So how can we do, so whatever we do with for loops, we can also do with while loops, right? And that is important to know. So while loop and for loops could be equivalent for different use cases, but it could make life easier when you have while loop in some of those instances. So let's see that sum of value that we had over here. How can we write it with a while loop? Sorry, not this one. So again, I'm gonna write sum of values. So we have this counter equal to 0, and then the index equal to 1 and equal to 20. So we want to find the sum of numbers from 1 to 20. So let's go ahead and make this 4, right? So that we have a better understanding of what's going on. So while this I is less than 4, less than n, which in this case is 4, we go ahead, make sure these are all changed. We go ahead and print that index, and we go ahead and print the sum so far, and then we add up that sum with this index, with the current index, which is then any number between 1, 2, 3, and 4. And in this case, 4 is included because this is less than or equal 4, right? So if this was less than 4, then it would cut this addition before we get to that point, right? And then we need to make sure that we are incrementing that I, otherwise we will stay in this for loop forever. And this will never finish. So let's see what this gives us. let me add a print here so that there is a space between these iterations. So we have I1 and the sum is 0. When we just start, the sum is 0, of course, right? And then when I goes to the next iteration, sum will go up 1 because we have added 1 to it. And then the sum goes to 3 because we added 2 to it. And then sums go to 6 because we added 3 to it. And then finally, the sum of values is 10 because in the final iteration, before this statement gets false, we have added 4 to that sum, right? So because I have got to 5, this statement has become wrong, and we get out of this while loop, right? All right. So I'm gonna put 2 quick exercises um, here. So please put in the chat what are uh, your solutions to these. You can have them in one line. So you can have it in one line for this, and you can have it in one line for this. So please put your answers in the chat. So I see one here, 0, 1, 2. I see 0, 1, 2, 4. I see 0, 1, 2, 3, 0, 1, 2, 4. Okay. I see 1, 2. I see 0, 1, 2, 4. 0, 1, 2. 0, 1, 2, 3. Okay, so we have 2 different answers here. 0, 1, 2. I think the main answer for the first one is 0, 1, 2 as I see it, and 0, 1, 2, 4 for the second one. I see some 0, 1, 2, 3s. 0, 1, 2, 0, 1, 2, 3. And I see 1, 0, 1, 2, 3, 4 for the last one. Okay, great. We see so many different answers. So let's go ahead and, okay, I see more. 1, 2, 3, 4. Yeah, great. Yeah, thank you all. So let's go and see which one is the correct answer. So in the first one, we have for I in range of 5. So we know that we go from 0 to 4. If I is equal to 3, then break. And break means that we right away get out of this for loop. So we don't see anything printed from 3 and onwards, right? So basically this should give us 0 in the beginning, and then 1 and 2. And as soon as we get to 3, then break. We don't get to this line, right? So if we go ahead and run this, we'll see 1, 0, 1, 2. In the second case, we go through the same iteration, but as soon as we see 3, we continue, and this means that we skip that step, so we won't print 3, and I becomes 4. So again, I is 4. We don't go through this conditional block, and then we print 4. So the only one that we won't print and we will skip is 3. So it's 0, 1, 2, 4, right? Yeah, thank you all for answering this. So hopefully this now makes it more clear. All right, so if we go back to the slide. So what are nested loops? So these are the loops within the loops, right? So now you can, so that you can, make it more complex. You have multiple, a loop going on within another loop, which gives you another dimension. For example, if you want to search through a matrix, you can use nested loops. So before I go to to the next slide. So I see a question that why the code was skipping 3. So the code is skipping 3 because if I is equal to 3, right, we will continue. And continue means we skip. We go to the end of the for loop and then let it to go to the next iteration. So basically, as soon as I is equal to 3, we hit continue and we don't go through this line. We go to this line and iterate increment I one more. Okay, cool. Now, let's see a couple examples on nested loops. So if I go here, now I'm going to think about 2 dimensions, right? So I'm going to define a matrix, right, in a Python list. Again, you haven't seen list yet. If this doesn't make sense, don't worry about it. It's just I'm just trying to add up 1 dimension to see how nested for loops work. But we'll see list in future slides. And this is how we iterate through that matrix. So we're saying that for row in matrix, right? And now that we have row in matrix, which gives us each of these rows, right? For elements in that row. So now that we have row from the first loop, now I go ahead and iterate through each of the elements of that row. And for each of that, I print that element. And then instead of going to the next line, I would just put a space and then go to the next element again until I finish that row, right? So after I finish that row, I go ahead and print null, which goes to the next line. So I print the next row on the next line. So if I go ahead and print this one, it gives me the elements of this matrix. So if this doesn't make sense because we are using a list of lists, then give it time so that we get to the final slide of this deck, and then we will cover that there. But this is how you add a for loop inside another for loop, right? So let me go over another example here, which is a little more complex, but it's a good learning for nested loops. So here we are trying to find the first pair of divisors for a number. So let's say for number 12, right? So the divisors are 1, 2, 3, 4, 6, 12, right? So the way we find this divisor is that 1 times 12 will be 12, 2 times 6 will be 12, 3 times 4 will be 12, right? So what is the first pair of non-negligible divisors for this number, which means that forget about this first pair, which is obvious. Any number has this first pair. What is this second one, or first non-negligible one, which is 2 and 6 for 12? So in case of 64, we have 64 is equal to 1, 2, 4, 8, right? 16, 32, 64. So these are the divisors of 64. So the first pair would be 2 and 32, right? So how can we use a nested loop to find this pair? So usually this would be an exercise for you to play with, but we're going to go over this step by step. And then you have enough exercises with those lead code questions after this in this class, and also some questions that you can work on at home and come back on the the day for solving those exercises later. So let's say the number is given as 42. We have a flag here which says we have found the divisors. No. So at this point, it's false. We haven't found the divisor yet, right? Now I want this to go from, uh, assign an index named as I and start from 2 and go towards this number, right? Exclusive, which means that this goes up to 63, right? So at any point, if we have found the divisor, just break because we have found it. And then after we break, we go out of this loop and then we can print we are done, right? So if we have found the divisor, that's it. But if not, then it skips the if condition when we go to this for loop. So the second for loop assigns j, and j also goes from 2 to 63. And if I times j is equal to that number, then this means that we have found the divisor, right? So we print that the first pair of divisors for that number are I and j. And then we set found divisor equal to true, right? Because now we have found the divisor. And at that point, we break. If not, we let j go all the way from 2 to 63 to see if it can find the divisor that complements that I. If that's not the case, if I is none of the divisors of 64, then this for loop finishes, and then we increment this I and go from 2 to 3 to 4 to 5. And for each of those numbers, we can go all the way to the end to see what is the complementary divisor that times I will become 64, right? So if I run this, it says that the first pair of divisors for 64 are 2 and 32, and we are done, right? If we go ahead and change the 64 to 12, it says that the first pair of divisors for 12 are 2 and 6, and we are done. Okay? So basically, this exercise here is to show you how can we use a nested loop to solve this kind of problems where we need to iterate twice, right? This can go on and on. We can have even 3 nested loops. We can even have 4 nested loops. All right, let me go back here. So best practices for nested loops is, first of all, keep the bodies of these loops simple and readable, again, as we had before. And then try to avoid excessive nesting because it's usually not computationally efficient. I know we are not talking about optimizing the code in this class, but it's always a good practice that see if you can minimize the number of nested loops because it could take a long time for it to run. Now, we also have seen nested loops and control loops in the example I just mentioned. So I'm gonna skip these couple of slides. All right. So before we get to functions, let me pause for a second and see if you have any questions. Okay, so it seems like there's a question on what does that end do in that code. Let me go ahead back here. So the question is why I'm putting this end is equal to this empty string here. So the reason is that for each row, instead of going to the next line, I'm going to see this space between the rows and continue printing on the same line, right? So as soon as we get to the next row, I'm going to put a print nothing, which makes this cursor go to the next line, right? And then for each row, the same thing happens, right? So if I go ahead and take this end out, this is what happens. So we have 1, 2, 3 on different lines. You have this print here, which goes one extra uh, step down, 4, 5, 6, 7, 8, 9, right? The other question is, what is the meaning of range 2 to number in the example we have down here? So let me show you what is this mean. What does it mean? So if I say range of 2 to some number, let's say 10, this is basically an object of a sequence starting from 2, going all the way to 10 exclusive, meaning that it goes all the way to 9, right? So if you want to see this, you can just simply put a list behind it to make it a Python list, which shows you the full sequence of 2, 3, 4, 5, 6, 7, 8, 9, right? So what you put here in this range, the first element is inclusive, and this is where we start. And the second element is exclusive, and this is where we finish the sequence. All right, now I'm gonna go back. Um, sorry, one more question here. So why are we starting from 2? The reason is that we are trying to find the first pair of divisors, not the obvious ones, and we're gonna skip 1 and 12 or 1 and 64. That's why we're starting from 2 and go all the way to 63, which is one number before uh, 64, right? So we start from 2, and then because it's exclusive, it doesn't count the last number. So basically, in this case, that number is 12. We go from 2 to 11. And what is the purpose of first if? So this first if in this code is checking if we have found the divisor, right? So as soon as we find the divisor, we put it equal to true, and then we break. We don't need to check anything else because we found the number which gives us I multiplied j is equal to 12, right? So as soon as we find that, it's set to true, and then we break, right? So this is what this line checks. Yeah, thank you for the question. So these were great questions, and this helps me, to clarify some of these points if I've gone too fast. No, the question is, does this breaks one layer of the loop? No. So this breaks the entire. I mean, as soon as you hit the break, you go out of the loop. So if found divisor is true, you hit the break, and then you go out of this loop. No more iterations. All right. So just to make sure we are on time, so we are at slide 56. We have a few more slides to go. So let me go back here. Now we're going to see the functions. So let me quickly answer the other question. So I see that the question is answered. Thank you. So I'm going to go over the functions now. Let me pick up this here. All right. So what are functions? So functions are reusable pieces of code that perform a specific task. It helps us to make the code modular. It helps us to make the code more readable, and it helps us to better maintain the code because it's much easier when you have these functions. Much easier to, for example, debug your code because when you get the error, you exactly know where to look for that error because now you have a function for it. You know that something's going on in that function. So it also helps you not to have recurring parts in your code because sometimes one function can fit many different places in your code. So it has multiple benefits. And so the way you invoke a function is you just call a name within your code, and then it is followed by parentheses containing their argument. So you'll see what all these mean in a bit. So as you can see, so you put DEF or definition for defining function name with the arguments here. Parameters and arguments. You should also have parameters here. And then you have the body of the function here. It could be as many lines as you need. And then you will return something. So this value also depends on what you need this function to return for you. So, and this is how you define, for example, this is an example of defining a function called greet. So this function doesn't get anything for its argument and only prints something. But we also see examples of functions that have multiple arguments. They could have any data type, and instead of printing something, they can return also something as well. So the return values that you see at the end of the function can return a value using the return statement that you have of whatever happens in your function. You can put them in some variable and then return that variable. You can also return operators. For example, you can return if you have A equals to 2, if you have B equals to 3, you can return A plus B at the end, right? So you can have that in your return statement. So if there's no return statement used, the function doesn't return anything. It just performs the whatever you have in the function and then gets out of that function. All right, so let's see a few examples now. I'm going to go over the next few slides and then I'll go over the code for all of it. So I mentioned parameters and arguments. So what is the difference between these? So parameters is the variables that are defined in the function in parentheses for the function in the signature, and arguments are the values passed to the function. So if I go ahead, for example, write a definition of some function, let's call it function, and I have A and B and some body of this function, and then return something, right? So these A and B, so these are called parameters, right? So whenever you want to call this function and you have this function 2 and 3, so you're assigning 2 to A and you're assigning 3 to B, right? So these are now the arguments. All right. These are the values that you're assigning to those parameters. So you can have default values for these parameters. So if you go ahead and define your function, again, like this, and then here you have A, and instead of just having A, have A is equal to 2 and B is equal to 3, what happens is that return something. So what happens is that when you want to invoke this function, you call this function function. So if you don't do anything and then just run this function, right? It considers A and B to be 2 and 3, right? You can go ahead and add another value here, like 1 and 5, and it complies with that. But if you don't add anything, it will go with the defined default parameters, right? All right, so I think now it's a good time to see those examples. So I see a question about the difference between the arguments in Python and other languages. So this is not Python specific, really. So in any language, you should be able to define parameters and then the arguments for those functions. But yeah, I mean, C++, Java is out of the scope here. So I'm not really, I don't remember how this was defined for Java. So I can look that up and let you know. But parameters and arguments, you should always have them if you have a function. All right. So let me go ahead and so I'm gonna define a function here called greet. So there's no argument for the greet. It only prints hello, right? So and then in our main body of the code, we call greet, right? So if I go ahead and run this function is only printing hello. There's nothing in return, right? So now let's see another function which is named greet someone, and then it takes a parameter, and this will become the parameter which needs an argument later when you want to use it. And then what it does is that it prints hello plus that parameter, right? So you may see some new stuff here. So I just added this up for best practices. You don't need to worry about it. If you don't have these extra stuff, that should be fine. But when you have type hinting, so this is called type of this variable, hinting, when you're defining a new function. So you have name, and you are specifying that it's a string. And then this part is telling us the output is a none, right? So this is a best practice, one of best practices when defining a function, so that someone who is using this function knows that what are the types of arguments, what are types of outputs, etc. So if I go ahead and run this, it gives us hello John, because John is now the argument assigned to the parameter name, right? So another example, I'm going to define another function called display info. So we get the first name as the first parameter, last name as the second parameter, and then we print first name and last name with those two, right? So display info, first name is equals ABC, and last name is equals to Eric. Maybe I can make this better example. First name is Eric and last name is Smith. And then the output is first name Eric, last name Smith. So as you can see, we are repeating the parameters here. We can totally skip that. So we can skip first name, last name, and then we get the same result, right? So let's see another example. Actually, what I'm going to do is I'm going to have this here as an exercise. So here I'm defining a function, right? And then we should get some output here. So in the chat, place your answer with all those answers. I'm not telling you how many should be. So you decide on how many outputs you need to put on the display, and let me know what's the answer. So I see that we have a 20 here. 20, 30, 20. So we have inside the function, we have 30, 20, 30, 20. We have inside function 20. So we have two sets of answers so far. So we have 20, 30, 30. Okay. We have 20, 30, 20. We have, again, 20, 30, 20 multiple times. We have 20, actually, I see a 30 for the last one as well. Okay, 20, 30, 20. Okay, so it seems like the predominant answer is 20, 30, 20, but I also see some 30s for the last one. Um, and I see, I think these are the only two ones that I see here. Okay, so great. Let me, okay, so let me go ahead and uh, show you why this is, I mean, I think the right answer is 20, 30, 20, but let's see why. Yeah, so we see 20, 20, 20, 30. So let's see why this is the case. So first we're assigning A to 20, and then we print it. So it should give us 20 again, right? Then we go through the function. So the function gets this 20, it adds up 10, and then prints it out, right? Inside function, so it should give us 30. Now, this print A doesn't know what's going on inside this function. So this is basically called a local variable, which you'll learn about on the next lecture. But basically, this doesn't know anything about what's going on here. So it should give us that 20 back, right? So this was a bit tricky, but now you know that whether we have A inside the function or not is important. So there is a way that you define this A in a way that inside the function understands this is the same A we're talking about, but that's out of the scope for today. You'll see that on week 2 of Python. All right. So let me, yeah, thank you again all for your participation. Let me go to one more example. So I'm gonna show you how the default values work. So I'm defining a new function which gets A and B as input, but the default values are 7 and 8. So if you don't add up anything for A and B, it will assign them as 7 and 8, right? So it finds the sum values and print it out in the display, right? So let's go one by one. So if we don't pass on any value as arguments to this function, we will get 15, which is the sum of 7 and 8, right? So if I go ahead and run this one, it overwrites the values of 7 and 8 to 2 and 3 and gives us a 5. So if I go ahead and only assign the first value, A is equal to 2, it gets that 2 for A, but B stays the same, right? Because that's a default value. So 2 plus 8 will be 10. So if we don't specify the name, right, and we just put 4, it goes and finds the first argument, the first parameter in the function, and adds this argument for that, and then lets the other arguments stay the way they are. So it basically puts a 4 instead of for 8, and then keeps 8 the same. So it basically gives us a 4 plus 8, which is 12, right? All right. So with that, we are at the end of the second section. So I see that we are running a bit out of time here. So it's 12:45 in my time. So it's fine that we go over time. So we need more time for these system strengths, but I'll try to make the next section, I'll cover it a bit faster. And then there are some examples, lead code examples at the end. I may skip some of the solutions just to make sure we are not going over time a lot. But let's have a shorter break this time. I'll go down to 10 minutes. So let's have a 10-minute break and we'll be back. All right. So let's continue. So Srinivas, I questioned in the chat, but I'm not sure if I understand it correctly. So is there a way to see the example syntax for a given statement in Jupyter, like pressing tab, etc.? So, I mean, do you wanna a demo syntax? You mean something like um, something like what we have here on the notebook? Maybe do you wanna maybe I can unmute you and wanna ask your question? Okay, so let me. Okay, so please go ahead.
Yeah, so I was more referring to when I said that define and that function, some template syntax so that I can see what are the options available in terms of the parameters or any other functions, right? Like that none between none parameter. While in Jupyter, is there a way that we can like whatever we type in, but we want to see any additional options available?
I see. So do you mean something like this? Something like this template, but what are
Yeah,
the options?
correct, exactly.
Okay, so basically, thank you for your question, Srinivas. So this is basically the main type, the main format of defining the function, right? But you can have different parameters, as many arguments as you want here, and you can also have different returns here, or even skip return and have no returns, right? So basically, what you see here on the screen is the most complete type of um, function that you can see.
But how do I know if there is a none like in one of the calls you utilized uh, return none? So how do I know that option exists? Like here in this case, right? If you scroll up a little bit, yeah, here we define a function which says none. The next one,
This one?
yeah, yeah,
Okay, this one.
yeah. So
Yeah,
how do I know
basically,
option exists?
so so this means that so you can still put return here, right?
Mhm.
So you still get the same output, right? So if I put return but nothing in front of it, right? So I will still get the same thing. So basically, you can always have this return as this template is showing, right? But if you don't want to return anything, you have also this option to comment this out and don't have any return. So the normal body of the function includes this return,
Got it. Thank you.
right? Yeah.
Thanks.
All right. So um, let me go ahead and. All right. So now I'm going to go a little bit faster to make sure we are on time. But I make sure that I still keep answering the questions, and our TA will also help out in the Q&A. All right. So now we're gonna get to the fun part, which is the popular data types in Python. So let me go ahead and. All right. So we have some very popular data types in Python, which we will only cover two of them today. but each of them have their own features, and it's really important to know all of them. There's a reason why we have multiple of these data types. So we need to make sure that we completely understand what are lists, what are strings, what are tuples or dictionaries or sets, and why do we need to learn all of them, right? So let's start with Python lists and then string. We see a little bit of slicing today, but then for week 2, we will cover these. We will have a recap of these things again before we get to other data types. So Python lists are created using brackets. So this is how we define a list in Python. And this is what makes it different from other data types. So they are ordered, they are mutable, which are really important features of lists. So by ordered, we mean that whatever you put in this array, and when I say array, I mean list, basically. So let's say we have a list called L and is defined as 1, 2, 3, 4. So this is a list, right? So by ordered, we mean that it's important what to place in the first spot and what to place in the second spot. So this ordering is important, right? So you'll see later that there are data types that it doesn't matter how you put, how you order these items, but the list is not one of them. And it's mutable, meaning that whatever you put in this place, for example, you're able to change in the future. So there are some data types, for example, tuples, that as soon as you create this data type or you define it, then you cannot change the values, right? So this is not one of them. So it's mutable collection of items. And a list can contain different data types. So for example, we can have another list here. Let's say items. You'll have A in the first place, and then you can have an integer 2, and then you can have a Boolean true, and then so on and so forth, right? So you can have different types of values in a list. So basic operations. So if you want to access some element of the list, you will type the name of the list, and then in brackets, you will add the index. So one thing to note is that the indexing, again, begins from 0 and goes to the last element, which is the length of the element minus 1. So it's exclusive, right? So we have L is equal to 1, 2, 3, 4, right? So if you want to access 1, you have to call the 0th element of L, right? And if you want to call 2, you will call the first element of L. If you want to call 4, you will call the length, which is 4, minus 1 of this list, which is L3, which gives us 4, right? So this is how it works. 0, 1, 2, 3. If you want to modify one of these elements, again, call that element and then assign it to a new value, right? So for example, here we can say L1 is equal to 3 or 10, whatever. And then this 2 will change to 10, right? If you want to slice this list, look at only one single part of it, then you can add start and end indexes in this bracket. For example, in this case, you can have L. Let's go from 0 to, instead of 3, let's go to 2, right? In this case, you will get the elements 0, 1. So this is exclusive of the last one. So this is basically saying L of, this is going to give us 1 and 2, right? So it's not going to give us 3 and 4, right? So it's slicing the list. So we can get the length of the list. So if we put len of L, it's going to give us 4, right? We can concatenate two lists, right? So list 1 plus list 2. is going to give us the concatenation of those two. For example, in this case, if I have L plus L, this is going to give me 1 to 4, and again 1 to 4, right? And then finally, we can have repetition of this. So if we put the star sign here and 2, so it means repeat L 2 times in one single list. So it basically gives us the same thing, right? Again, some of the very important characteristics of Python lists. They are ordered, they are mutable, which means that we can change the values. They are heterogeneous, which means that we can have multiple types of data types in one single list. They're dynamic, which means that at any point of time during the code, we can add or remove elements, so the length can change over time. And it can have duplicate elements. So, for example, in that same list, we can have 1, 2, 2, 3. So you can have a duplicate, right? So you will see that later. We have data types that do not allow duplicate data. So here are some of the methods built in for lists, for appending, to add an element to the list, for extending the list with some other lists. If you want to insert something to the list at some specified index, if you want to remove some element, if you want to remove an element and get that element or return that element so that you can use it later, we can use pop. If you want to clear out the entire list, you can just simply write clear. Index, find an index of something you're looking for in the list. Counting an element in the list. You can sort the list based on the values inside it. For example, if you have a bunch of numbers, you can sort them from low to high values. You can reverse the a list. So if you have 1, 2, 3, you can make it 3, 2, 1, right? And then you can also copy the list and have multiple lists of the same thing. So a couple other points before I go to the code. So we have seen this before, but again, you can iterate through a list. So if you have, for example, a list of 1, 2, 3, 4, you can iterate through it and get any of these values and then do some operation on these values. So you can put this in a for loop and iterate through this list, and then do some operation and get out of the for loop. There's also some way to do this for loop in a compact way, right? So it's called list comprehensions, that you form a list, and then within that list, you write your code in one single line saying expression or item in that iterable if some condition holds, right? So instead of writing for some iteration and then if something happens, then the expression, else something. So you can put all of that in one single line within this bracket, right? We'll see example of this as well. And then common use cases. So there's so many use cases for Python lists. But transforming elements, filtering elements. If you want to generate a new list out of the previous list, we can define matrices. Lists are really useful when you work with NumPy arrays that you'll see later. It's really compatible. You can just switch between lists and NumPy arrays very easily. So there's so many use cases for lists. So that's why we are seeing this in the first place among data types. All right. Now, with that, I think it's a good time to get into the code. Let me make sure that, okay, so we have practice, and then we go to the next topic. So yeah, it's a great point to see now some implementation. of lists. All right, so we go here. Let me start by defining a new list. So I'm gonna create a new list of some fruits, right? Apple, banana, and cherry in this list. So I'm gonna run this cell. Now we have defined the list, the fruit as a list of 3 elements. Now, first of all, we want to see that lists are ordered. So when we assign index, it is meaningful for the list, right? So fruits 0 should give us the 0th element, which is apple, and fruit -1 should give us the last element. So this is one other point which I wanted to tell you at this point, which is we have negative indexing as well, and we will see that on a slide later, that if you add -1, it begins from the very last element in that list, right? So if I run this, it gives me apple, which is the 0th element, first element here, but 0 because it starts from 0, and cherry, which is the last element, right? So we also learned that lists are mutable, which means that if you have some element here at index 0, you can switch the value. So here we'll say, let's call the first element here, or the 0th index of the list, and then we assign grape as the fruit for that element. And then we'll see that we can switch that to grape. So let me define another list to show you that we can very well have different data types in one single list. We can also add, let's say, false, something, some boolean here. And now I'm also gonna use the slicing. Going back to this fruit example, I'm gonna use slicing to get only the second 2 elements. So this starts from 1, which is banana, and then goes all the way to 2, 1, 2, and it is exclusive of 3, which doesn't exist. So we should get banana and cherry back, right? So we can get the length of the list. So for example, for this list that we defined, ID list, we can get the length and assign n as that length, right? It is 4 because it has 4 number of elements, right? And we can concatenate the list, right? So if I go ahead and have 2 lists, one is 1, 2, 3, the other one is 4, 5, right? So we can concatenate these two and get this new list, which is 1, 2, 3, 4, 5, right? And the last example I wanted to show you was multiplication of lists. So if you have a list which has only 1 0 as its element, then times 10 gives you a list of 10 zeros, right? So these were just some basics of defining lists. Now, let's see a few methods for this list. So I'm gonna go ahead and define this uh, list again. All right, so we have the list of fruits, including three fruits: apple, banana, cherry. So I'm gonna go ahead and append orange to this list of fruits. So basically what append does is adds this new element to the list that we have. So we add the name of the list first, dot append, which is a built-in function for any list in Python. And then we add this new element, which is orange. And this is what happens, right? So we add orange at the end. So when you append something, and because the order is very important, these new elements will be added at the end of the list. So now I'm gonna extend my list with a new given list, right? So I'm gonna add this list of kiwi and blueberries to this original list, which now has orange as well. So I put the name of the list dot extend with a new list given here. So make sure that you see the difference between extend and append. Append is only one element, and you can just add that element here in this way. But when you want to extend your original list with a new list, then you need to make sure that the input to this function is a list, right? So in that case, we will get that original list with orange added, and then these two new fruits are added to it as well. So let's see what happens if I'm going to also add a new fruit, but let's see what happens if I don't put this bracket. So something funny happens actually. So it considers this new string as a list of characters, right? And then adds all those characters to this list, right? But this is not what we're looking for. What you're looking for is to extend that list with a new list. So we need to make sure that we add that bracket, right? So right now, if I add this, then it will keep all these characters and also add watermelon to it, which is not what I want. So I'm going to go ahead and uh, define this list again and do this, right? So from this list, now I'm going to remove something. Let's go ahead and remove cherry from this list of fruits. So I would say name of the list dot remove that element, right? And we don't see cherry here anymore. Now, let's say I want to pop some element out of this, pretty much like remove, but I'm going to get that element and assign it to some variable, right? So if you remove something, you won't get the value. So if you pop something instead of remove, you also get the value. It returns something, right? But if you don't say which one I'm going to remove, it pops out the very last element of the list. So if I get that element, it says that the removed element is watermelon from this list, and then the new list of fruits is whatever we have without that watermelon, because we popped out the last element and we returned the value to this removed element, right? Let me go ahead with a few more cells. Now I'm gonna pop again, but now I'm gonna say I'm gonna pop the second index, which is 0, 1, 2. I'm gonna pop orange this time. So I assign the index that I'm going to pop from this list. And then this time it pops out orange, and you'll see that it doesn't exist in the list anymore. So at this point, I don't need this list anymore, probably for some reason. I'm going to clear it out, and then you'll see that the fruits has no elements inside it, right? So this is how clear works. You don't need to put anything as argument. Now I'm going to see how indexing works. If you want to check the index for something inside your list. So I create that list again, apple, banana, cherry. You have 3 elements. I'm going to see what is the index of banana, right? So I will get 1 in the output because it's 0, 1, right? So let's see what happens if this item doesn't exist in this list. So let's say banana, I have a typo here and I have NA again. So I will get an error, right? So it says that this item that you're looking for doesn't exist in the list. So you need to make sure that if you want to find the index for that item should exist in the in your list, right? Um, all right. So let's go ahead and add one more element, right, to this list, which is apple. So now we have apple, banana, cherry, another apple. Now we want to count the number of apples that occur in this list, and this is how you can do it. So fruits or the name of the list that count, and then you add that element, right? So then this uh, returns a value that we're assigning to number of apples, and then we print that, and it says we have 2 number of apples. So if you go ahead and change this to cherry, it says you only have 1 number of cherries in your list, right? All right, so let's see some other examples of methods in Python. So, and I can go back to this slide to make it. So I'm gonna define a new list. So it's called nums or numbers. So I have 2, 0, -1, 4, -2, 10, right? So I'm gonna go ahead and sort this. So if I put the name of the list here, dot sort, then it sorts that num and it happens in place, meaning that after this line, this list of nums will change. And then if we print it, we'll see that it sorts from the minimum to the smallest number, from the smallest number to the biggest one, right? So it sorts the integers. So if you have, for example, if you have names here or strings, right? So let's say we have this list here, right? And if you want to sort that, let's see what happens. So if you have fruits.sort, let's see what happens with that. So as you can see, it orders it based on the alphabetical order. It looks at the first character of each string and then orders based on that, right? Okay, so now let's get back to our numbers here. So we can reverse this list. So we can use reverse with parentheses to get the opposite direction of it's basically descending now, not ascending. We can copy a list to a new list, right? So we can have nums.copy to a new list. And if you print it, it's the same as the original list. So we can delete elements from this list. So for example, I have this list of nums. I want to delete the second value, which is 4. So delete nums. What gives us is the same list without that value, right? And again, we can have only a part of that list displayed in the output. Sorry, deleted and shown in the output. So, for example, in this case, I'm deleting indexes 1 and 2 from this list. So here we have 10, 2, 0, so I'm deleting 2 and 0, right? So it's exclusive of 3. So it only deletes the second 2 elements. All right. And these were some examples on Python list method. And I'm going to also give you a couple of examples on list comprehensions. But before that, let's see how we can iterate through the list. So I'm going to define a new list here, 12, 3, 4, 5, 20, right? And I'm going to iterate through this list. So this is how we should do that. So I'm going to say that for elements, and this could be anything. This could be I, this could be index, whatever you want to write. For elements in nums is this list. And when we say in nums, it means that iterate through this sequence one by one, right? And each time print elements for me, right? So it goes through this sequence one by one and prints that element. So first time element is equal to 12, it prints that element. It goes from 12 to 3, prints that element, so on and so forth, right? So if I run this, we get these 12, 3, 4, 5, 4, 15, 20. And again, if you want to put this in one line, we would say end is equal to an empty string, and then we have it in one single line, right? So there's another way of printing out these numbers, and it's going from the first element to the last element. So we define n is equal to the length of the nums list, right? So now we know that n should be what? Should be 5, right? So let's print it out. Yeah, so we have 5 elements here, so n is 5. Now, instead of doing this thing here, right, we say that for I, now instead of looking at the values of these nums, go for the indexes, right? So in range n, which is giving us from 0 to 4, 0, 1, 2, 3, 4, right? Print nums of that index. So in the first place, I is 0, it prints num 0, which is 12, right? So in this case, this element, this thing here was itself was 12. But in this case, I is an integer. It's not a, it's, so in both cases are integers, but I is not the value 12, but it's 0. But nums of 0 is equal to that element that we had before. So I go ahead and place again, and then if we print it out, we'll get the same result, right? All right. So one last example is how to check if an element exists in a list. So in this case, we know that nums has 12, 3, 4, 15, 20, right? So one of these elements is 4. So we're saying if 4 exists in nums, then print yes, present. But if this is not the case, then no, not present, right? So this is basically checking if this element exists in this list. This is how we can use in um, to check that for existing nums, right? So this part is basically our condition. So this is either true or false, right? This is what we had before. So because in this case it's true and for existing nums, it goes ahead and prints yes, yes present, right? And the last thing is list comprehension that I wanted to show you. So let's say um, for values of 1, 2, 3, and 4, we want to print out the square, uh, squares of these values. So, before what we would do is that we would go for a number in 1, 2, 3, 4, right? So we would just print a number to the power of 2, right? So this is what we originally would do if you wanted to iterate through this list and then print out each number to the power of 2 or square root of that number, right? This is what we would get. But we can do this in one single line. And what we can do is um, we can say num to the power of 2 or num in 1, 2, 3, 4, right? And the output will be a list of those squares. So basically, we are creating a new list. Instead of going through this for loop, we would say, this is what we want to see in the list. And for these values, right? So for num in this list, one by one, perform this operation, which is find the square, and then put that in the list that um, actually we do care about. We want to see in the output, right? So this is called list comprehension. Instead of going through a loop, you create a new list in one single line. So let's see another example. So actually, I'm gonna add this as an exercise. So I'm gonna say with list comprehension, uh, give me a list um, for which contains even values from, let's say, from 0 to 10, right? So from 0 to 10, write one single code of list comprehension that um, the list only shows the even values from 0 to 10, and 10 should be exclusive. So this is what we want to see in the output: 0, 2, 4, 6, 8, right? One quick hint is that if you want to add a condition, again, I will say that you have to put an if condition at the end, right? So this is a hint. Give it a shot. So I see one answer here. I see the second one, x for x in range of 10 if x is even. I see a couple more. See a couple more. Yeah, this is great. I'm seeing a variety of answers. Yeah, great. So I'm gonna give my answer to this, but I encourage you all to go ahead and, because I see a variety of answers, we don't have enough time to go over them one by one, but I encourage you all to um, go over your answer, place them in your notebook or your editor, and see what happened, okay? And why it doesn't work. But if I want to put this here, so I will say, what I want is all the numbers or all the x for x in range of 10, right? So from 0 to 9 inclusive, I want to look at all the numbers and only accept those numbers if x modulo 2 is equal to 0, which means that if x is an even number, then keep that, put it into this list, and go over to the next number, right? So if I run this, it will give me 0, 2, 4, 6, 8. I saw some of the answers similar to what I just have here, but I see also different answers, which um, doesn't necessarily mean they are not correct. I see some folks using print list of range, so that is also correct. But we wanted to see how list comprehensions work in this case, but that's also um, the case, so it's fine. All right, great. So with that, I think we are done with list. So there are a couple lead code practices which I will skip for now. So I will see if we have enough time at the end. I'll get back to this and then we cover a couple of those practices. But let's make sure that um, we cover all the material first and then we go over those exercises. All right, I go back here to this view. Now, we have seen Python lists, right? The last piece would be strings, which is another data type, not just in Python, in almost every single programming languages, but we'll see how it's defined and operators work on strings. Um, so I see a comment that the pace has gone a bit fast. So I'm gonna, because we have one more topic to cover, and this has to be aligned with the content of the second week. And as you will see, strings and lists are similar in some aspect, right? So I want to make sure that you see strings and lists in one place. So I'm gonna cover string as well, and then that would be the end, right? So I want to make sure that we see strings and lists in one place. But this will be the last topic. Um, if you have time, we can go over a couple uh, practice flip code problems and then call it a day. All right. So from lists, now we move towards strings, and strings are also ordered, but unlike lists, they are immutable, right? So before we saw that we can change the values of lists on different indexes, but strings, when you define a string, let's say you define a string called A, B, C, D, right? You cannot make any changes to these values. So Python thinks about a string as a list with all these elements, right? But the difference between strings and lists is that you cannot make any changes to the values of these indexes, right? And again, as we had before, you can define a string both with double quotes and single quotes, right? So basic operation, again, for strings are very similar to lists. So you can have s of 0, which gives you a in this case. You can have two strings concatenated exactly as we had with Python list. So here we can have s plus s, which gives us a, b, c, d, and again a, b, c, d, right? And we can have repetition for strings. If here we have s times 2, we have a, b, c, d, a, b, c, d again, right? So it will be repeated 2 times. We can find the length of the string, exactly similar to what we had for lists. And one thing which is new here for strings is that you can, uh, you know, convert all the characters in the string as uppercase or lowercase, or even replace the characters with other characters. So you cannot change the value, but you can find all the characters with some value and then replace them. I see the question about changing the character using the index. Yes, we can do that. We will see it in a slide. So like lists, now we have string methods. So these ones we already see, upper characters, lower characters, partitioning a string, pivoting around some character, replacing or finding a character. We will see how we can remove some trailing characters at the end, and how we can split a string around some particular characters. And if a string starts with something or is numeric, and then back to the question, the index of some character in the string. So let me go back to this slide. So when we say that a string is immutable, right? It means that if you have s is equal to abcd, if I go ahead and write s of 0 is equal to n, which means that I want to change this a to n, this gives me an error, right? Means that you cannot, it's immutable. You cannot change the values of the characters. All right. So Um, Slicing of strings is exactly as we saw for lists. So it is used to extract a portion of the sequence. So let's say, again, we have the string is equal to A, B, C, D, and you only want to take a couple of the elements, right? So again, you can look from some, start looking from some index and go in a sequence to some index. And as before, you can also jump. You can have steps. So for example, we can start from A, jump over B and look at C, so on and so forth, right? So slicing works for all these data types when the sequence, when we have the ordered set, then slicing works the same. Um, so start is where we start indexing here, end is where we end the slice, and end is exclusive, it doesn't count. And then depth is that depth size that we want to cover that slice, right? So if there is no step, the default is one. So the step will be one by one. And we'll see examples of this in the code. And then again, like we had for the list, negative indexing has a meaning as well. So for example, when I say S is equal to ABCD again, right? S of -1 gives us D, because if you have -1 here, it means that go ahead and look at the last element of the string and find the value. S of -2 will give us C, right? So I believe that will be it for the for strings. And now I'm gonna show you the code. So I'm gonna have examples of replace Lila in a minute. So we'll see how it works. So you cannot assign a new character, but you can replace them using the function with some other character. Let me go over that one by one. All right. So I'm gonna open up my notes on strings. All right. So let me define a new string. So let's say I have a new string called greetings and it says hello world, right? Now, what we're going to do is we're going to access the characters, right? So we say character is equal to greeting, the first index. And because it's an index, we go from 0, 0, 1, it should give us E, right? It gives us E. Um, so back to the question, when we say strings are immutable, what do we mean? So let's say in this string, instead of H, we're gonna uh, assign G, right? So this assignment is not allowed for strings, right? This is gonna give us error. We cannot, so this was not the case for list, but for strings, you cannot assign different values, or you cannot even assign anything, right? Because it's fixed, it's static after you define this string. So how does the concatenation work? Let me. So concatenation means that you have one string, which we had before, and now you have another string, right? So you just simply add a plus sign in between. So this is why when I was showing you the operators, I told you that this is not just for arithmetic. It could also work for uh, a string or list concatenation. So if we do this, we'll get hello world, have a great day, which are a concatenation of these two strings. And how about repetition of the string? So here we are actually repeating star 5 times, and we have a string in between, and then we repeat star 5 times, right? So this is how the output looks like. So this is how we can repeat a string and then concatenate it, and then concatenate it again with a repeated string, right? And you can also get the length of the string using len in parentheses, and this gives us 13. This means that this greeting here, it has 13 characters in it, including this gap, this white space. All right, so let's look at the methods of strings that you see on this slide. Let me zoom in a bit. So we have this method and the slicing, and we'll be done with the content. Um, so let me add up some skills here. Okay. So let's say we have this string, cat, dogs, lions, right? And we wanna move everything to uppercase. This is how we do it, right? So we have the name of the string dot upper, right? And then what you see in the output is all caps. Now we can do the same thing with lower. So instead of upper, we have lower here. And make sure that you have these parentheses because it's a function call. If you don't do that, you'll get the output. And so if we have that, we'll get this output. And then I don't put this parentheses there. It will just show you what type of a object is it, right? So you need to make sure that you're calling that function with these parentheses. So there's one other method called capitalize, which you don't see on this list here. I just wanted to show it to you as well. So capitalize is basically uppercasing the first letter and lowercasing the rest of it. So as you can see for string Elizabeth, now we get the capital E, and then the rest of it is lowercase. So what's partitioning? So partitioning is, so let's say again we have this string of words. Then when you partition around a given string, you look at that string, right, and partition it before and after. So this becomes the pivot in your string, right? So it looks at dogs and then puts everything before that, whatever you have in the string, and whatever you have after that, and dog will be in the middle. So if I go ahead and instead of dogs, I remove all these letters and only keep D, right? Then it partitions around that D in the dog, right? So it gets cats all the way to D, and then D, and then all the way from there to the end of the string. So this is how partitioning of a string works. If I go ahead and put a blank and single white space, then I'll get the first white space and partition everything before and after that, right? So this is how partition works for string. Now, here's how replace works, right? So we have a string here, apple, banana, apple. And then we want to replace, wherever we see apple, we want to replace it with orange, right? So this is what we can do for strings. We cannot do assignment, but we can do replacement. We need to use this built-in function. So if we do that, then we go ahead and change all the apples to oranges, right? What we can do is we can choose how many times we want to do this replacement, right? So, for example, let's say we have apple, apple, apple 3 times, and we only want to switch the first two to an orange, right? So if we want to do that, then for replace, we add another argument saying that we want to do this for the first 2 times, and we get orange, orange, apple. If I don't put anything here, then it will interpret it as I want to change all the apples to orange. And if I go ahead and put only one, it interprets it as I only want to do this once. So look, as soon as you find the first apple, switch it to orange, right? Okay, so let's see how find works. Let's say we have this text here, and then we want to see what is the first index where we see a world inside this text, right? And then the output is 7, which means that you go from here 0, 1, 2, 3, 4, 5, 6, 7. And 7, which is a W, is where this thing begins, right? So what if there is no world in this text, right? So let's say instead of world, I say uh, Python, right? So I'm asking in this text, where does Python begin? And it says -1, which means that I cannot find Python in this for you, right? And one last thing for find is um, that what we can do is we can um, narrow down the search space to the number of index of those characters, right? So for example, we can ask find world inside this text, but start looking from index 25 and go to 35. And in this case, it will skip the first world and then goes straight ahead to the rest of the text and find 29, which is the index of the first character of this world here, right? And if I switch from this one to this one, I'm saying that now narrow down your search space from character 5, character 15 in this text, and it finds 7, which is the first character of the first iteration of world in this text. Now I'm gonna show you what is this R strip. So R strip is basically a method to remove trailing characters from the end. So let's say we have a piece of text here, which has some trailing white space. So if we, uh, have this R strip for that text, right, without anything inside it, then it goes ahead and removes all the white spaces here. So if I run this, it says the result is this thing, and as you can see, there's no white space at the end. So it says the original length was 18, and I removed 3 white spaces, and the new length is 15, right? Um, but this is not only for white spaces, we can have it for characters as well. So here I'm saying that let's say we have banana and plus a dot at the end, right? So here we're saying that from the last character, whenever you see each of these things, pop them out until you get to some character that is not equal to any of these, right? So here we have N, A, and dot. So we start from the end, we remove dot, we remove A, N, A, N, A, because these are all the characters that we see here in this set, right? And then it only keeps P for us, right? So if there was no A in this, so I'm asking it to remove N and dot from the trail, right? It only removes dot because there is no, it gets to A and A is not here, right? So these are just some extra information that may help you, but the important thing about our strip is that removing white space, it could be very helpful, for example, in NLP applications. But yeah, just to let you know about it. So how does split work? So if you have a string like this, and we want to split over white spaces, we can simply add dot split after the text, and it gives us a list of split, um, the pieces of this string split over the white space. Yes, Kanul, I'm working on it to make sure that you'll get these slides. I'm so yeah. I'll make sure that the slides and the code will be shared with the class. So I see a question on not following the previous example. Let me make sure that this is clear. So we're gonna remove some of the trailing characters, right? So here we specify what are the characters that we're gonna look at when we are removing these things from the end, right? So if it was only dot, we are saying that look from the end. As long as you see a dot, remove them and keep the string clean. So if you have multiple dots here, then this basically goes ahead and remove all the dots, right? Now, instead of dot, um, yeah, exactly. So instead of dot, if we also have a, then we are saying that not only remove dot, also remove this a here. But as soon as we get to this n, because we don't have that n here, we stop, right? This is how it works. Hope it makes sense now. All right. So let's see where were we. Yeah. So this is how a split works. But now let's say we want to split around a fixed character. So let's say we have this string, and we see these commas here, right? So we want to split whenever we see a comma. So if I run this, then you'll see that we get that uh, separation. But now instead of the white space, we look at the commas, right? And then again, we can also specify how many times we want this split to happen. So here, for example, if we don't specify the maximum splits, we will get 1, 2, 3 splits around this comma. But what I'm placing here is that go for a maximum of 2. So one split here, done, right? And this is what happened. And this was for a split. One more method I'm gonna add here is join. Um, so if you wanna do the opposite of splitting, if you wanna join these two strings, right? So this is how you should do it. If you wanna join them with a gap between them, you specify that gap, dot, join, and then the name of the string. So this is a bit different from the previous case where you have the name of the string, dot, and then the method. Now you need to first identify what is that separator, right? How you want to connect them. And then join these elements in the list into a string. So now your input is a list, right? So you have hello plus white space plus world, right? And let's say you want to do this with another character. You have apple, banana, cherry, and you want to join them in one string with a comma and a white space, right? Here's how you do it. So this is basically the opposite of split. The next method is start with. So we want to see if some string starts with something. Um, so the default is, for example, when we have a text like this, we want to see if this text starts with Python. So this is simply adding the name of the string dot starts with and the string, right? So this gives us true. So basically our string begins with true. So let's say instead of Python, we have pyth. This still gives us true because the string begins with pith. But let's say instead of pith, I have mith, myth, and this gives me a false, right? And the other way is that exactly uh, similar to what we had for find, to find some index in a specific limit, slice actually of the string, we can have that defined here. So I want this to search elements 7 to 9. This is exclusive, and see if there's an is there, right? So I run this and it gives me true. So basically going from 0, 1, 2, 3, 4, 5, 6, 7, which is exactly where this begins, to 8, 9, 10, there is a is here, right, in this slice. So that's okay. Now let's say I'm gonna put 9 to 12 here, and this is gonna give me a false because that string is not gonna start with is necessarily. Um, is numeric checks that if all the characters in that string are numeric characters or digits, basically. This says true, right? But if I have some characters or letters here, this is gonna give me false, right? So this is what that is numeric will do. So we can also check for alphanumeric. So alphanumeric is basically number letters, right? So if you want to do that, we will say uh, the name of the string dot is ALNUM, is alphanumeric, right? So this one is alphanumeric because we only have letters and numbers, but this one, for example, isn't because we have letters, numbers, and this exclamation mark, which is not alphanumeric. So this gives us a false. And the last method I wanted to show you was the index, right? Um, so the index is giving us the first index that we see when for this given string in the original string. So if you run this gives us 7 because world begins from 7, right? Um, but unlike find, index gives us an error if this doesn't exist in that text. So this is the main difference between find for a string and index. So index, you need to make sure that your string exists within that original string. But find will give you a -1. That's not the case, right? So it pops out an error. And then you can also narrow down the search again. And if I go from 8 to 12, then I get an error, right? Um, And I'm gonna give you one exercise, and then I think that will be it. So let me go to the slicing. We have seen the slicing by now. So let's define this list from 0 to 9, right? And I see a question saying that depending on how you want to handle exceptions, and the answer is yes, Alejandro. So basically, the difference between find and index is index shows an error when you cannot find that, and find gives you -1. So uh, let me first remind you how this slicing works and then give you this exercise. So we have a string saying coding is fun. And then if I want to look at a part of the string, we write it this way: string, the name of the string, and one column 5, right? So this is basically giving me 1, 2, 3, 4 because 5 is exclusive. So it gives me in the output ODIN, right? Now, what I want you to do, I have some stuff here. I want you to think about each of these and see what will be shown in the display for each of these things. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 in the output. So a couple hints. So when you see two columns, so when you see one column, you just saw the example here, right? So when you see two columns, the last index, so this is start and this is the step, right? That you want to jump over some element. When there is no element defined between columns, it goes with the default values. So here, if there's no element, it goes from 0, and second, on the second spot, if there's no element, it goes up to the very last element, this list. If you see a negative, this means that you should start from the last element, which is -1, -2, and -3, right? And then if you see, I think that's all. Now you should be able to uh, work on this. So I'll give you a couple of minutes, work on these examples, and use Shift Enter to give all the 9 lists in the output. So I'm gonna give you one more hint. So I see results are coming out. So the other hint I wanted to give you was um, this is basically uh, going backwards, right? So this is when we say steps are -1, it means go backwards in the list. So I think we also haven't seen this as well. Okay, so I see a couple answers. First one, 1, 2, 3, 4. Second one, 1, 3, 5, 7. Any other answers? Third one, 0, 2, 4, 6, 8. Mhm. So if the index is out of range, we'll see what happens. So I see that there's a comment there that list 10 gives index out of range. But we'll see what happens with that, right? If it's out of range, then there's no element of the list to show, right? I have a 0, 2, 4, 6 for the third one. 0, 2, 4, 6, 8. 1, 2, 3, 4 for the first one. Full list for the fourth one. So 7, 8, 9, and 5, 6, 7, right? 9, 9. Okay. 9, 8, 7, 6, 5, which is the reverse order. Okay. I see more answers coming in. Good. I see 7, 8, 9 out of range. I see 2 out of range. 5, 6, 7. Yeah, there are a couple of them missing here and there. Um, so I see that. So let me go over this again. So we have when we don't have values in column, right? It means you go with the default. So for example, in this case, if there is no value here, it means it goes from 0, right? If in the second place there is no value, it means it goes from, so what's the length of this list? It's 10, right? So it goes from until 9, so 0 to 9. And when there's no value here, it means that it goes with the step size 1, right? So when there's no value, you go with the default. Yeah, I see many more inputs, so that's great. I see that some of the answers miss a couple points, which makes sense. But this is great. I mean, it's great to see all the answers here. I see a couple of nuns for these two that begin from 10, right? Um, okay, so let's see what happens for each of these. So let me go one by one. So this is basically what I was referring to in the previous example, right? So from 1 to 5. So we basically skip 0 and go 1, 2, 3, 4, right? So this is what we get, 1, 2, 3, 4. The second one, so let me start adding this print to make sure it looks better. So the second one says, let's go from 1 to 9, which is this one, right? So it's 1, 2, 2, 3, 4, 5, 6, 7, 8, and 9 is exclusive, right? So we go up to this point, and then we jump every other element, right? So we have 1, 3, 5, 7. So we have 5, 3, 1, 5, 1, 3, 5, 7, right? So let's add another print here. So what does this one give us? So if we have the values default ones here, which is 0 and 10, or we have, actually it should be 11, right? Because we go from 0 to 10, and if you want that to be included, it should be 11. So I think I made a mistake previously. So the default is n plus 1. So it's basically saying that go from the very first element to the last, and then jump from every other element. So it's basically 0, 2, 4, 6, 8, all the even numbers. Um, okay, so far so good. So this one has all the default values. So basically, whenever you see this kind of thing, it basically means the entire array, right? And let's go ahead and add a print. So this one is saying go from the end of the list. This one is -1, -2, -3. So start from -3 and go onwards, right? So it will give us 7, 8, 9. All right. So this one is saying start from -5 and go all the way exclusive of -2. So it's -1, -2, -3, 4, 5. So it wants us to begin from here and go all the way to -2 exclusive, which means 5, 6, 7. 5, 6, 7. Now, here's the controversial one. So this is saying start from 10, right? So if you count this, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 9, 10, right? Um, so start from here and go to the last item, which is itself in a reverse order. So basically, because this makes it exclusive of the last one, it doesn't even begin to count, right? Because we are saying that start from this element, but stop from some other element which we want it to be exclusive. So in that case, we do not even have any starting point, right? So basically it becomes 0. So if I change this 10 and go to 9, we are basically starting from this um, 8 elements and then go exclusive to 9. So basically we have only 8, right? Oops, sorry. So that would happen if you had this to be 1, because we're going to the right. If you're going backwards, then we don't have any element, because we're starting from here, we go to the end, right? So if that is 1, um, yeah, sorry. Actually, I'm making a mistake here. So going from 0 to 9, going to -1. So if this is 8, yeah, I think yeah. So what if I start adding this 1 here? Yeah, I don't know what was I doing wrong, but if we start from the 8th element here, right, and we go to the end and we go with steps of 1, um, then we only get 8, right? So if we go with steps -1, which means going backward, we shouldn't get anything, because we cannot start from 8 going backwards, and this will be our last element, and there's no values between, right? So I hope this makes sense. Um, okay, and then similar thing for the next one. So if we start from 10, which is basically this element, right? Um, or actually 10 in this case is one after this, right? And then going towards the last element with steps of -2, this would also give us an empty array, right? Um, and then the last thing will be this one, and this is basically similar to what we had here, and then going all the way backward, right? So the default values here, because we're going backwards, start from the last element towards the first one. It's basically doing that reverse function for lists again. So yeah, I mean, this was quite a challenge. So I got a little bit stuck at this as well. But I think with that, you have seen all sorts of um, slicing of a list, and exactly the same thing applies to strings as well. So you can use the same ordering, um, forward and backwards um, for strings, and also for other data types that we'll see on another lecture. It should be applicable. Um, so yeah, um, let me make sure that I know that you're over time, so I think we're gonna skip the lead code problems for today. So you'll get access to these slides. Please go ahead and add it to your list of practice problems. We can see that with what you've learned today, with these data types and if and else and the loops, you will see that you'll be able to solve some of these, or at least understand the solution to these problems, right? So what we covered were some basics of Python, variables, data types, operators, arithmetic, logical comparison, inputs, typecasting. So we saw some if and else um, statements, how we define them, how we define loops, while loops, for loops, how can we break a loop, how can we continue and skip some iteration in the loop. Now we know how to define functions in Python, how the parameters or arguments work, and how can we return values from the function. And then finally, we saw some data types, some most popular data types in Python that are very helpful. And actually, this is not a comprehensive list because we'll see tuples, sets, and dictionaries later in the course. But yeah, please go ahead and use all these tool sets for those lead codes that we didn't get the chance to cover today, and also other problems in the practice set. So with that, and make sure that you provide feedback for the class in the polls. So that would be super helpful for me to improve my instruction skills, and also for interview kickstart for improving the content. So that is really helpful for us. Thank you for providing that. And yeah, so with that, this is gonna be the last slides. So I'm gonna stick around a bit to see if there are any questions. Otherwise, thank you so much for joining. Hope this was useful for you. And yeah, let me know if you have any questions. And I'm gonna connect with the organizer team to see how I can share these slides and the resources with you. Thank you all.
Hey, just a quick question. Are you teaching the next class?
So I think I'll be teaching
The first one, right?
So let me quickly check on my calendar. I think I'll be teaching something next week. So next week on Sunday, I'll be teaching Python Fundamentals Week 2. So
Okay, it's for this cohort, right?
I'm not sure really, Lawson, because I don't see the cohort under my class, but I can check that. Yeah.
Just curious. Are you going to touch on the? I mean, this is very good. I mean, I like your way to touching the nuances, because those are making a huge difference. Are you gonna teach like a function as a first class object pass into and pass out of a function, and in the meantime like a descriptor, that kind of thing, or those things are not as important as I think it is in your line of work?
So first of all, thank you very much, Lawson. It's great to know that this was useful for you. So your question is about function descriptors. So basically, you're asking that do we get back to functions in our next class?
Yeah.
So so next class would begin from these data types again. So I think we won't get back to functions, but we will use it throughout the week for for different use cases. So there's so much to cover on this 4-week program. So I'm not sure if you're going to get back to functions at that point. But we will be using functions again. But so what was your question, Lawson? Is that something we can address right now, do you think?
No, not really, because it's going to be a long topic. Like object-oriented programming, I'm pretty sure you're going to touch someone in the, and
yes.
Like a property, are they going to touch on the property besides the data members and attribute and method, and also the descriptor, that kind of thing? Are they going to touch on that or?
So that's a good question, Lawson. So that is week 3 in this program, and I haven't taught that yet. So I haven't seen the content. So that is something I need to check.
Hello?
Can you hear me?
Yeah, you got cut out a little bit.
Oh, sorry. So I was saying that that is a content for the third week, and I haven't
Okay.
taught third week so far, so I'm not sure about the content. So I need to check that out to see if that descriptor is explained on week 3 content.
Okay, got it. Thank you. Then one more
Thank you for
question.
a question.
In terms of LeetCode, LeetCode
Mhm.
is a website which do we just I mean, how do we cover do we have to cover the LeetCode ourselves, or we can just use what you asked us to do in the class, like the 5 or 6 questions you list out within the LeetCode?
Yeah. So the lead code questions, you don't need to have access to the website at all, right? So you can see the questions here, right? And then you basically use these examples. So you just write a function for each of these codes in your own editor, right?
Mhm.
And then you just go ahead and define your own examples and see if your code is working okay. And just for your reference, the solutions are also here within the code.
I
Right? So
see.
when you look at this solution, forget about the class part. Just define this function on your end, and then this will be how you need to code it up. And then this is your reference for if you are looking for solutions.
But in terms of LeetCode itself, is it important for us to use LeetCode to practice, or you don't think it's relevant for
Um,
future interviews?
yeah, I mean, if you're so having access to lead code is good in general. I mean, if you wanna have that um, editor which you can run your code. It gives you the complexity of your code, and you can see the discussions. People have different solutions. There's a community, and you can stack up your solutions and see which one of your solutions is more efficient. But in the scope of this class, right, you don't need any of that. This is just to make sure, and the solutions that you see on this slide is just to make sure that you can have something which is running, right? This is not by no means any optimized code.
Yeah.
So basically for that, you don't need lead code to make sure that you understand these concepts and you can run these codes, right? But if you want to get to the next level, try to optimize your code and see if you can run the code, if it actually runs on so many different test cases, and how you compare this code with the code of people in the community, then you can go ahead and work on lead code directly.
Got it. Thank you.
Hope it helps. Thank you, Les.
Thanks.
Yes, yours. Thanks for an excellent session. I know it ran a little over, but thanks for covering the great details. Really appreciate that.
Yeah, thank you so much, Srinivas. No, that was a pleasure. Thank you all for staying to the last minute. I know it's overtime. I try to do a better time management for the upcoming classes.
No worries, it's worth it for going through the details.
Thank you.
So one question I have, Siavash, like I just want to touch upon. So the question that I had was like when you hit a list and you put the period and then you hit the tab, it gives you all the possible functions that can be done on that list, right? So what Python can show. So with that way, if I'm a newbie, I could see that, hey, it gives me all the list of possible functions. But yeah, here, like I can see that.
Yeah.
In the same way, is there a way that I'm just asking if I don't know if it's possible or not, but in Jupyter, if I want to see that, hey, when I'm writing an append, is there any example that it can show or or a function that I'm trying to write a function? Does it give me a template kind of how it looks, what are the different possible options? It's like a help document kind of thing.
I see what you're saying. So basically, you're looking for the same thing, but for function.
Correct. Or more here also, how it just lists the function, but is there a way that I can get some example of it if I want to in Jupyter right away from the well while entering my code here?
Yeah, I don't remember anything for defining functions, but I do remember using already existing methods that you press on tab and then you see all the options, like the arguments that you can add for that specific function. So I don't have
Oh,
any examples on top of my mind, but one thing maybe we can check is
because right now I go to Google to see how it, what is the syntax of it or example of it, or what are the other alternative functions that I can do on
mhm.
top of.
Yeah, so I'm trying to see if I can find any example to have. Yeah, so can you see this? Can you see my screen?
Yeah, yeah.
So basically, and this is out of the scope of this lecture, but just to show you. So I have this NumPy package imported, right? And I
Mhm.
call that package, and from the random library of that package, I want to see what are the options. So basically, think about this as a method or function in this numpy.random package, right? So
Correct.
I add these parentheses and I click on tab, and this is giving me all the possible arguments that we can put
Arguments.
here, right?
Got it.
So this
Oh,
is adjusted for this specific method for NumPy, right?
oh, okay.
So I have seen this in so many different packages. So for example, if you use scikit-learn for machine learning, right? So you'll see that as soon as you want to use any of the methods to, for example, with the train test data set, whatever, then you press on tab, you see all the options that you have, um, you know, as parameters of that function. So all of these packages, right? If there's a function you want to use, if you want to write a function from scratch, no. But if there's a function you want to use from already existing libraries, there are great documentation on each of those. So you should go to the document. I mean, even if you don't need that, I would still suggest that you look at the documentation and see all the arguments that you can pass on. So sometimes you're not aware of some arguments, and then you realize that if you knew that, probably you would probably use it, and then that would make life much easier.
Correct.
So this is how I go about it. But yeah, I'm not sure if anything on top of
Got it.
this exists.
Okay. Sure, sure.
Yeah,
Thank you. Thanks a lot.
yeah, absolutely. Any other questions?
That's it. Thank you.
Yeah, of course. So I see a hands up. Um, see a hand up here. No. Okay. All right. So okay. Sudhakar, if you wanna go ahead.
Uh, yes, siavash, adding to what Srinivas has asked, uh, uh, so yeah, to see everything in a function, like the doc string or what all the parameters that we can pass, do you think we can try with the shift tab option? So taking the same example, the random function you said, like if you give a shift tab on that, it gives you some kind of
Oh, okay.
arguments.
This way.
Yes.
Okay. Yeah. Thank you for bringing that up. This is great. Yeah. So, Srinivas, if you can see on the screen, so instead of tab, I clicked on Shift tab, and
Oh,
now we have kind of a mini document of what is available to us in this case.
yep. Thank you, Siavash. Thanks,
Right?
Sudhakar. I
Yeah.
appreciate that.
Thank you, Sudhakar. This was great to know.
No problem. Thank you.
Yeah, thank you. Any other questions? I see one more hand up. Yes, Gopinath, please go ahead. I'm not sure. I see that you're unmuted, but I cannot hear you. Any other questions? All right, so I will also take a look at the Q&A and okay, I see that you mentioned you have a mic issue, Gopinath. It's okay if you have any questions, please feel free to put in the chat. I'll be around for a few more minutes. I'm trying to see if I can answer the other questions. So, apply if we know ahead of the time schedule for the class. So yeah, I see a comment on the schedule for the class. So actually, this was my first time teaching this week one of Python fundamentals. I'm sorry that this went over time. I'll make sure that from the next classes I do a better time management. So I basically spend a lot more time in the beginning comparing to the end, but point taken. So I'll make sure that, or if I need time, I would go ahead and let the class know in the beginning. Thank you for the feedback. So the activity for the class, Gopinath, so first of all, is this lead code problems that I didn't get the chance to go over. If you have got some exercise problems, you should be able to go over those as well. If you haven't got them, it means that you probably need materials from the second week of Python to be able to solve them. But this is a good question. I can reach out to our organizers. But yeah, if you don't see any exercises in the resources of this week, that basically means that you have to wait for the second week, and then there will be problems provided to solve on the next Thursday after that. So practice set 1. Okay, great. So I see that your comment on the week 1 practice set, which is unlocked. Great. So you have access to that, and you have 6 more problems from today, which we didn't get the chance to cover. One more time, but this is, yeah. Thank you, Lila and Justin, for the feedback. Point taken. I make sure that we don't go much over time. So I see a question here. Why list is not the same as that? Okay, so basically the question is why is these two things different? So if I go ahead, so we have one list saying column, -1, which gives us a reverse list, right? So the question is, why isn't this list and this one 0, 0, -1 the same? Because this should just give us an empty, if I'm correct, right? So because this starts from 0 and ends in 0, but 0 is exclusive, it doesn't matter if we go forward or backward. So it's gonna always give us null, right? All right. And we have another question saying Python practice set week 1 has 9 problems and 1 multiple choice question set. Supposed to be reply in the one question. Sorry, no worries. Thank you very much for mentioning that, Justin. Never mind the extra time. Yeah, that's great, Srinivas. So I'm happy that this was helpful, and hope that you learn new things in today's class, and I make sure that I try to manage my time better for the upcoming classes. All right. So thank you, everyone. If there are no other questions, then we can call it a day. Thank you so much for joining, and hope you enjoy working on the problems based on the toolset from today. So yeah, see you next time.